artificial intelligence, this term we are hearing for last 70 years. But all on a sudden, there is a more interest in this topic. Why? Because we know if anything is useful, if anything can be converted as a use case, then its importance increases. So this is the same case with the artificial intelligence. Now we have been hearing for last 70 years. Okay, so the recent sudden surge in AI use. This is in agriculture regarding extension, disease identification, in medical science also regarding early disease identification. So there is a recent sudden surge in AI use. Why? The first thing is rapid adoption of generative AI. Earlier it was predictive AI. Now it is more use of generative AI. That is easy to use, and also no code AI. Earlier it was the domain of the computer scientists. Now with the little use of code, we all general people also are able to do some AI work. So that way there is a rapid adoption of generative AI, and so also the use of AI in our daily life. Then the second thing is that while we were studying, we were not able we were not acquainted with the also keyboard of a computer early time. But now there is a robust digital public infrastructure, internet connection, computer, so many things, and the government of India is also giving huge importance for this aspect. Rupees 20,000 crores in 25-26. This is for AI research and development. So huge investment is there, huge public infrastructure is there. Strategic government initiative. Now India AI Stack, that is the dream project of Honorable Prime Minister. 9 crore farmers, they are now enrolled in this India AI Stack, and 30 crore land holdings are now digitized. So digital agriculture is taking place at a very fast rate. So that is also helping the use of AI in agriculture. There is a high adoption rate, massive database also being generated, a young skilled workforce, about 1.25 million young technocrats will be generated by 2027. They will also help. And the most important thing is that it is easy to use. There are several use cases in which we are using AI. So we will be restricting to agriculture and allied sector. I will be sharing some of our experiences. The first thing is chatbot. Actually in 2023, this chatbot, that is generative agriculture, generative AI helped us, and this year on 17 February 2026, Bharat Vistar, that is released, and it is a very, very good initiative. We can ask using this chatbot. This chatbot, we can ask about best practices, crop selection, weather information, government schemes, what government schemes are running, and how farmers can get benefit from that, what is the market trend. All these things we can get information from this Bharat Vistar. Bharat Vistar captures farmers' query. They have Bharati assistant, virtual assistant Bharati. They will reply, that she will reply to our farmer query, retrieves, and relevant information is given. And that important thing is from authentic sources. From usually in Google search we get so many information, and we have to identify which one is correct, which one is wrong, and how it is useful. But here authentic government sources are embedded, so we can be getting authentic information. This number, farmers can just dial 155261. Of course, call cost is to be borne by the farmer. That automatically from his mobile, that call cost will be borne. But through this 155261, we can get all these informations what we have discussed. Advantage is authentic organizations like Department of Agriculture, State Agriculture University, research institutes, marketing cooperatives, all government organizations, including water resources, IMD, all such marketing organizations. So that information is authentic. And advisory is provided besides agriculture, cattle, buffalo, poultry, fishery, and other domestic animals. Any information we can get. And privacy and trust is also included. And before this Bharat Vistar, initially it started with Mahavistar. Mahavistar means that was for Maharashtra state in the Marathi language. The farmers are using it in a large scale. In the first year itself, 0.4 million, but 4 lakh farmers they have actively using, and 22 lakh downloads have happened. So naturally, if it is useful, so 4 lakh people are using actively, and 22 lakh people have already downloaded it. So that way, Bharat Vistar will also extend to other languages slowly, and that will bring a good revolution in AI use in agriculture in India. Second aspect is image recognition for diagnosis and recommendation. D and R, diagnosis and recommendation. This will be largely useful like Plantix. In Plantix, we can show the disease symptom and we can get information. Another, this Plantix is very useful and used. And See and Spray. See and Spray is the computer vision that is also being used for identifying the weeds. And this is of course not in India, in USA mainly. Still in USA, 8 million hectare area is covered in the year 2025. 8 million hectare is not a small area. So that way it is useful and farmers are using, and we will also use it. This is about Plantix. The query, take a picture. We took a picture with our mobile. Then that app will tell whether it is a disease plant or a healthy plant. If it is a disease plant, then they will recommend what will be the control measure for that disease. So in this case, it was papaya mosaic virus, and the app identified the disease and also gave recommendation. See and Spray. This is a tractor in which computer vision is mounted. It is slowly moving. When the particular weed, this is a soybean crop, and when a weed comes, then that will stop there, and a nozzle will automatically open. The particular herbicide will be sprayed on that particular place. So that way we can save huge amount of herbicide. It is reported that 77% of the herbicide use will be less. That is a very big thing. If 77% of herbicide use is reduced, so that is a very useful thing, and 8 million hectare is already in use. Then another thing is cotton plant aspirin. This is mounted on 50,000 tractors. They will identify, while moving in the field, they will identify the pests and diseases in real time. Another thing, this plant village. Plant village, it is in use, and it is 5 million farmers in Africa and Asia. So that is similar to our situation, Asia. So 5 million farmers in Africa and Asia are using this plant village that is specific for identifying 38 crop diseases. And in Kenya and Malawi, it is successful for early management of diseases. And we know if we can identify early the disease, then with little pesticide we can control that. So that way our pesticide use will be useful. And this is Kenya, Malawi, they are using, means that is also applicable for our situation. Not much high-fi technology is not required. So plant village, this is the crops list, which crops are covered in this plant village app. As for example, this in maize crop, that army follower, that is a very important pest, new generation pest, and that app is asking, please press the proceed button to check your plant for fall armyworm. Press the yellow button to scout your field. Then we press that yellow button, that please scout for this my field, and they will scout, and the number of fall armyworm in that field, that is given, and we are accustomed with this ETL, economic threshold limit, and accordingly if it has crossed or it has reached the ETL, then immediately we will go for control measure. And in India, cotton bollworm is a very important pest, because that boll, they will be infested by this bollworm and they will cut the fibers. So all our investment is useless. And that is a very important economic pest for cotton crop. And in Punjab, what they have used in the year 2025, they have used the AI technology, pheromone trap they have taken, and in pheromone trap this pest is attracted, and that is attracted to this trap, and the camera will count how many number of cotton bollworm have reached this at this particular stage, and then that information will be immediately converted and communicated to the system AI app, and accordingly the control measure was taken. In 2025, this app helped in controlling cotton bollworm in Punjab state. So the Punjab government has ordered for more such units in Punjab. That is a use case, or that is a real application case, and a very useful app. That the technology is developed by CICR, Central Institute for Cotton Research in Nagpur, and the Punjab government has ordered for requested for more such units to be established, so that they will control the cotton bollworm. In 2025, they have got success, and subsequently they will be getting that benefit. Cattle eye, that is for cattle. Suppose cow in good commercial farms, large number of cows are there. So their health is monitored through camera. Our NDRI, National Dairy Research Institute, Cornell, they have also taken some such step. This cattle eye and Kaitas, these two apps are foreign use, but our NDRI, they have also developed. The camera will take the photo. The photo will indicate about the movement of cattle's foot. If it is not normal, then they will have some different foot movement. They will have some different eye movement. Their body temperature will be different. So all these observations were taken by the sensor. They were converted using AI tool, and final result was coming. As for example, the cow is not sleeping well. That means it is some health problem is there. And if 1 hour rest time is less for the cow, then 1.6 liter milk production per cow will be less. 1 hour if it is not taking proper rest, normal suppose 8 hours rest, and if it is taking 6 hours, then 2 hours it is not able to take proper rest. 2 hours means 3.2 liter milk production will be less, and accordingly milk production can be predicted earlier. Similarly, our SIFA, Central Institute of Freshwater Aquaculture, they have developed some automatic opening of a fish feeder. Fish, they are whether demanding fish feed or not. If there is no demand for fish feed, then that feed will be wastage. And nowadays fish feed is very costly, because from sea fish that will be converted to fish feed and that is marketed. The fish feed rate is increasing like anything. So even this cow feed, the rate is increasing like anything, beyond the reach of the normal farmers. So if we can save some amount of fish feed, cattle feed using this AI app, that will be of great use. So the automatic fish feeder is they have developed, and another ICR institute that at Barakpur, CIFRI, they have developed automatic BOD recorder. So biological oxygen demand of the water in the farm pond, how it is. So Sometimes fish dies in large numbers if BOD level rises and there is some problem. So that automated BOD system, that is useful. ICR SIFA also, they have developed automatic fish harvester. But all these things are nowadays costly and not beyond the reach of farmers. So the technology has to be refined so that our farmers can use that technology. This cattle eye, cattle eye, here there is a camera, and camera is taking a photo of this leg, the body, other parts, and that is converted to 0, 1, that binary language of computer, and this information is converted. Next thing is about predictive analysis and a data-driven advice. Here also sensors, satellite imagery, drones, they are using. Suppose in a village there are 20 ponds. Drone will fly over it, then what is the area of the farm pond, what is the depth of water, for how many days water was there, and how that volume of water can be converted to irrigate crops. That can be but drone is also a costly technology and not easy, so much spreaded. But these are the future technology in which the young generation should think and they should develop use cases. Another thing is drought, flood, cyclone, pest outbreak, and we know actually in most cases once a drought has occurred, drought has done some degree of damage, then we go for contingency measure. That way we are not able to control, to manage the drought properly. Similar case is the pest outbreak. Suppose this BPH, brown plant hopper in western Odisha. Suppose we are taking measure after some damage has occurred. So that way we are doing some economic loss. But here we can have early identification and early control so that pesticide use will be less, the drought management will be easy, flood management will be easy. AI in precision farming, here our institute, Indian Institute of Water Management, we have done something. Here the MB1030, that camera is, that sensor is used, that is a ultrasonic sensor. So that sensor records the depth of water inside a rice field. Suppose this is a transplanted rice field and nowadays water is scarce. So we are recommending alternate wetting and drying in rice. Of course, farmers are not adopting it because farmers cannot tolerate little loss in yield. They will not tolerate. Water is not important for them at the present situation. For them, yield should not go below their expectation. So here, but our aim is to reduce water use in agriculture, in rice. So here in this field, we are recommending alternate wetting and drying. Drying means if the field is no ponded water. No ponded water means we cannot know now that what is the depth of, what is the ponded water depth or height in the field. And we are recommending that the IRI, International Rice Research Institute, is recommending the water level should be 15 centimeter below the soil surface. And below the soil surface we cannot see. So they are recommending IRI pani pipe. IRI pani pipe. So pipe, that perforated pipe is installed in the field and the water level goes down from surface to slowly. And we observe now it is 15 centimeter below, so we should irrigate. That is a manual procedure. But here we used a sensor MB1030, that is a ultrasonic sensor that will send some sound wave, and when it reaches the water level, that will bounce back again to the sensor, and the sensor will calculate what is the depth of water. So that way we can know what is the depth of water. We may not go to the rice field from our home. We can see from the app that now the depth of water is inside my rice field is 10 centimeter, 15 centimeter. Now it is high time that I should irrigate field so that 5 centimeter of ponded water is on my field. I have told farmers are not in a mood to give yield loss, and in this AWD there is some 5%, 10% yield loss is there because of water deficiency. Farmers are not adopting, but this is a future technology, and in future if required it may be useful. And this other thing is IoT enabled soil moisture sensor VH400 that is manufactured in USA, and we imported and we used for recording the soil moisture. Here also the popularity is not much. We tested in Varanasi, Indian Institute of Vegetable Research, in this present photo in NRC banana at Trichy, and in wheat crop, in other crops, different centers. The sensor is working to satisfactory level, up to 80%, 90% it is working to a satisfactory level. But unit cost is about 20,000. 20,000 for farmer, it is a huge amount. Really, farmer will not adopt this technology at present, because 20,000 rupees he will pay, and because farmers are quite well experienced. This technology is useful for foreign countries. For India, our small farm means 1 hectare area. For other countries, one small farm means minimum 800 hectare. So 800 hectare, that is big patch of farm for small farmers, and it is 8 hectare. Their classification is 8 hectare. For us, it is only 1 hectare. So we can easily visualize, we can know. So for us, it is not much useful at present. In other countries, they are using it. AI integrated robotics, that is not at present useful for us. Like chatbot, this is weedbot. So the tractor is moving, and the computer vision is identifying weeds, and a robot that is uprooting mechanically, because it is a robot. This is the other case was a herbicide use, and this case it is a uprooting manually, and this is 90 to 95% accuracy in identification of a weed. AI is the brain, and actuators or sensors are the body. Like our brain and our body, the brain here is AI, and body is the actuator, the robot. AI and variable rate technology, this is also not applicable for us because their farm is very big, in a big 800 hectare farm. Some patch is low fertility, some patch is low water, some patch is weedy. So that way, this variable rate of technology is useful. For us, not much use, but CIA, Bhopal, they have trying, and also CRRI, Kotak, they are also trying. But to me, it will not be useful for us. So based on this discussion, what will be our futuristic insights? What is possible that we can use for our own situation? Bharat Vistar, it will spread like anything, because that is giving authentic information, 24/7 service, and low connectivity areas. Because even with our system, we tried to some interior places, it was difficult. Even in our farm at Mendasal, we faced many problems. Actually, we say something, but while going for this high-tech really there is a problem, and we have to be up to date for that purpose. But this Bharat Vistar, they have taken care of this low connectivity areas also, that will be covered, because they are using SMS-based system. So for future, this will be a very good technology. Image-based D&R, diagnosis and recommendation. For also human beings, we are not able, and doctor scolds us, why you are coming at so late stage. Similarly, in our agriculture, in our viticulture, in fishery, animal husbandry, everywhere, early identification is the key. So that with little pesticide, with little medicine, we can get over of this year. Suppose BPH of paddy in western Odisha is a very big problem, and a huge loss is there. So some of us can think of that how we can develop some AI, so that early identification of a BPH is possible. Rice hispa in Assam is a very big problem. After flood, this pest increases like any number, and if we can identify in the early stage, then we can do something. Fruit and shoot borer in brinjal, that is a perennial pest almost, and a regular pest, and so if we can have some early identification, that will be useful. Early blight in potato, blast in upland rice. Similarly, in fishery, animal husbandry and poultry sectors, we can think, use cases, and my request would be our seniors, they are having good knowledge in subject. Suppose identification of pests, our SARs are here, they have good experience, and this our new young generation people, instead of using chatbot and other things, WhatsApp for so many hours, they should take help from our seniors. They should learn how, sir, we can identify early. This is the key, that early identification. Early identification means with little medicines, we can save our environment, we can save the expense of our farmers. So in Banana Institute, they are trying to early identification of viral diseases so that they can take some, because banana is a monocarpic fruit. Once that center is damaged, that crop was damaged, a huge loss for us. Similarly, paddy is also monocarpic. The main pillar is damaged, means main panicle is gone, like so my request would be the younger generation, they should interact with our seniors, the subject matter specialist, get some information and do. And the third aspect is analyzing market trend and supply chain. Here our scope is there. We can know the market price, we can predict how much rice production is there, how much this cotton production is there, how the price of the market is going to change. All these things we can use from this information. And the fourth is agricultural education. Agricultural education, here actually AI will bring big revolution, use of AI in agricultural education. I will cite one of my example. I had published one article in CABI, Commonwealth Agricultural Bureau International, CABI, that is, they have a journal, CABI Agriculture and Bioscience, that was on integrated rice fish farming system. So after publication, they got some merit from the paper. They observed that perhaps some practical utility is there, some use case is there. So my publication was in 2025 January. In March they sent one mail that whether you want to publish your information as a use case. Nowadays use cases are also being getting popular. But last 3 years, 24, 25, 26, only the last 3 years, because we are printing so many papers, but all are not use cases. They are not useful for a practical use. So I just ignored that they may ask something, some dollar, why I shall go for this. I just ignored the mail. Then after some time, another mail came that we have sent this mail, whether you are still interested for publishing it as a use case. Then I read the detail. There is no mention of money. So I agreed. And after 2 months, they sent me a manuscript, and that was AI generated. So, and I went through the draft, because this is a computer-based thing, based on computer-fed information. Some wrong informations were also there. So I corrected the manuscript, but beautiful thing is that good new informations were also there. I had some experience, but I am not fully aware of all the subjects. Some soil water engineering aspects, some fishery aspects, some new aspects were also entered through this AI. And I was not sure that whether all informations are correct or not. I was apprehending, but wrong informations what that I deleted. Then I sent the revised manuscript. Then they improved something, and now they have accepted, and they will publish as a use case. And the use case here in this example means that will be a teaching material, that will be used by teachers, that will be used by the students for the international community. And so that way in our education, agricultural education, that will be very much useful. So I will be saying one thing, that professors, good professors, their knowledge is always respectable, and their knowledge plus AI still better. So quality data plus AI is always better than quality data. First thing is good professor, good quality data. So my sincere request would be publish 2 articles, 3 articles, but it should be of practical use. It should not contain false data. That is, I may be wrong, but people are doing just copy and paste and adding wrong things, just guessing things also. they guessing, he has published something, and I have published something. He had written 10.5, I will make it 11, 9, that way, and I will. But that is a very bad thing. Suppose I had done some mistake, that mistake will be increasing and increasing. That will spoil our system. To whom we are bluffing? To our own farmers, to our own students. So that way we should not do this. But AI is very useful to get new insights. So only senior professors, the actual field workers, they will be able to identify what is the false thing, because they have the experience, and they will embrace these new things, and our agricultural education will be improved by like anything. Barriers are many. Digital literacy among farmers is less. That is, even US farmers, they also expressed that there is a complexity in the technology. It is not easily adaptable. Our situation is still worse. So there is digital literacy is low. Our small holding is 1 hectare, only 1 hectare. They have 800 hectare, much big, and moreover, 87% of farmers in India are small holders. So we have to think this way, that our technology should suit to the smallholder farmers. High investment cost, as for example, our that soil moisture sensing system, AI based IoT enabled system, that is 20,000. 20,000 rupees is a huge amount for our farmers. So for our situation, we have to think whether instead of spending 20,000 rupees for knowing whether my field is now ready for irrigation or not, whether there is some other alternative. As for example, in sugarcane field, we want to irrigate, when to irrigate. But in this 1 hectare sugarcane field or 1/2 hectare sugarcane field, on 5-7 banana plants we can put in center, on some sides, upland side, lowland side, and we know the banana crop is more sensitive to water stress than sugarcane. So before sugarcane demands water for this field, the banana crop will show early symptom. So that is a very easy thing. So that way also we have to think for our farmers. Technical complexity is there, and adverse environmental footprint is also there. With AI, also benefit with there. Adverse effect with AI, how? Because of carbon footprint, and yesterday we were discussing even our sensor MB1030, it has some carcinogenic effect. That way it is harmful, but it is also useful. How? Because if we can go for early identification, then our pesticide use will be very less, our fertilizer will be used less. So that way we can save inputs and we can have good carbon footprint for our environment. So we have to weigh how much gain and how much loss. So my last request would be, we should develop proper use cases for our situation, for our small holding, for our farmers. Thank you. And quality data and wrong data is very harmful. That is magnifying the mistakes again and again. So please do one experiment, but correctly, and report correct data. So with this, I completed my presentation, and we can have some interaction. If time is there, we can at the okay, sir. So yes, sir. Please.
Thank you so much, sir, for this very insightful talk. Now we will directly start our oral presentations. So, first of all, I will request G. Pramila, Research Scholar OUAT, to deliver first oral presentation.
very good morning to everyone present here. My name is G. Pramila. I'm a PhD scholar from OEAT. I'm here to present the topic Leveraging AI for Sustainable Food Security, a case study on sesamum cultivation at Denkanal district of Odisha. This is under the theme of technological innovations including AI for sustainable food security. So firstly, I would like to say that what are the contents are there in my presentation. That is, introduction is there, study area, methodology, what the results and discussion, and then the conclusion. So firstly, I would like to say that why we choose in this sesamum. As we all know that sesamum is also, we call it as in different languages with different names like til, gingerly, sesamum, like that. But it's a very age-old crop. It's a very ancient crop. We used to use it very previously. Why? Because it is oil-rich crop, where we also call it as the queen of oil seeds, and also it is rich in protein. It is having a its hull is also can be used as a whole seed. So along with this, apart from all this oil content and protein, it is also having its medicinal value. So, but we can say it like nowadays the sesamum cost is being increased a lot. Sesamum oil is very beneficial. I think in my childhood, my parents or my grandparents, they used to give me all the time. They used to ask me to eat sesamum oil because it is very iron rich and all, so that the bone will be strong. So for that reason, they used to eat it continuously, and now also we can see our grandparents are very strong with those like millets and this sesamum and all. But nowadays, the consumption of this age-old crop is getting very much low because of the cultivation is getting less. So for that reason, what we have to do is, even though in different countries and different places of India and different places in Odisha, the cultivation is being there, but the productivity is less. You can see here, in different countries like Myanmar, India, China, Sudan, Mexico, and Nigeria, all these places, production is there. And India, we are contributing about 24% of the world's sesamum area, 17% of the production, but we are having back with the productivity that is about only 351 kg per hectare. In India, we are cultivating in different states like West Bengal, Madhya Pradesh, Gujarat, Uttar Pradesh, Karnataka, Tamil Nadu, Andhra Pradesh, and also Odisha, where productivity is highest in West Bengal. In here also we are looking back. In Odisha, the area under sesamum cultivation is about 260.62 thousand hectares. So, why we are getting back? The cultivation is in marginal and submarginal lands, poor crop management practices, even though sesamum is required of very less amount of water, the water requirement is less, even though the management practices are, we can go with that. But then also here, crop is affected by a number of diseases and pests. So, in all these reasons, now this research is went to see what is a suitable land for cultivation of sesamum crop. So, by combining this precision agriculture, which is a very good tool, like where it is included with the remote sensing, Internet of Things, artificial intelligence, that will help us to get the data, spatial data, like where we need, what amount of land is available, what amount of sources is available for us to cultivate the sesamum. Not only sesamum, this can be done for different crops, but particularly now we are focusing on this particular crop. So, by using this precision, agriculture, what benefits we have? We can early identify the stress of a particular crop, decrease use of fertilizers and pesticides, we can see the water stress, and also the combination of this artificial intelligence and precision agriculture can help us to boost the sustainability of these sesamum farmers and also many other crop farmers for making the scheduling irrigation and also the fertigation, thereby improving the yield and water efficiency, etc. So, for this reason, the study area we selected in Odisha is Denkanal, where it is also one of the area of the Odisha where sesamum cultivation has been done. So, the study area that they have conducted is 4,452 square kilometers of Denkanal district, where it receives a rainfall of 1,000 to 1,600 1,600 mm rainfall, and the soil type here we can see is red lateritic soil, sandy loam, and alluvial soils. So coming to the methodology that we have used here is ArcGIS, where ArcGIS 10.8 can be used to manage, collect, analyze, and visualize the spatial location and locational based data. So soil mapping, soil fertility analysis can also be done with ArcGIS. Especially we are using this to see the land suitability for Sysamum. For that reason, this GIS is being used. So, and then by collecting, here the methodology is given continuously, but I'll also explain the step-by-step procedure that has been involved in this. So firstly, we have to take the spatial data, and then the union function is being used in the arc map, and then we need to unite all the maps, and then the key indicators which are being collected includes like the topography, land slope, annual rainfall, soil type, and the flood risk. All these key indicators have been considered. So, and they are compared with the suitability classes that we all know, that high suitability land, low suitability land, and which is not suitable. So these kind of parameters are considered. So here it's a pictorial. Yeah. So here we can see the overlay techniques where we use the ArcGIS. So we need to collect the elevation maps, slope maps, rainfall maps, soil type, flood risk map. All these are individually. Then within this GIS, will give a function of union function where the individual maps are being combined as one, and then by using this attribute table analysis, we'll compare with the suitability classes and will give the final suitability line. So here is a it is a diagrammatic representation, and here it is an example. I'm not giving here. I'm not giving the data of the research because of it is a lengthy data, like 3 years or 4 years of data, so I couldn't present here. That's why I'm giving here an example. So in the after taking the individual maps of soil, elevation, slope, etc. and all, by using this union tool, we'll combine all, and then in the attribute table we can get, it's a kind of Excel sheet where we can see what is the soil type in that particular area, what is the rainfall it is getting, and what is the slope of that. And by comparing with this suitability classification, which is already we are having, high suitability means ideal conditions, moderate suitable means acceptable conditions are there, marginal suitability means poor but can be used for cultivation of Sysamum, not suitable means it cannot be supported for the cultivation of Sysamum. So here the score is given and the slope is given. So slope will get by the suitable classes, but score will get by using the field calculator use, which we get in the ArcGIS automatically after giving the union maps. So as a whole I have given here, and then final suitability score that we have to combine all these scores, 5 plus 3 plus 1, all these scores if we combine individually, if we get a sum up of all these scores like area score, slope score, rainfall score, soil score, elevation score, flood score, whatever the parameters we are taking, if we combine all those, the final sum up which we will get, if it is high, then we can say it as a suitable person, if it is a suitable place. If it is low, we can say it is not suitable. If it is moderate, we can say it is moderately helpful. So by considering or by taking all these steps, what the result we have got here is, out of the area 2,477 is highly suitable for Sysamum cultivation, and moderately suitable is 664 area is moderately suitable, and the other is marginally suitable. And then, so here we can say that this study categorizes the land suitably into 4 main classes. That is, the major one is 74% and moderately is 18%, and the other is 7.3. With these findings, what we can do is we can suggest farmers which part of land can be suitable for cultivation of Sysamum, and then which part is not suitable, so that that area can be converted to some other cultivation. Instead of growing in the non-suitable areas the crop, instead of doing that, we can suggest them to cultivate in the area which is suitable for cultivation of these parameters which are suitable for the Sysamum cultivation. So that's what we can help the farmers to go on for their cultivation, and this can be helpful. Moreover, recognizing the various levels of suitability that can stimulate further initiatives and discussion. And also GIS-based spatial modeling not only deepens the understanding of land characteristics, but also serves as a valuable tool for informed sustainable land and resource management. And these are all the references. Thank you. I hope I managed my time. Okay. Yeah.
So audience, please. At the end we will.
Yes.
At the end we will go for question session.
Yes. Thank you.
Thank you, Pramila, for the beautiful talk. Now, let me please invite Bedagi Pavan Naik for the next presentation.
Good morning, everyone. Myself, Badgi Pavan Naik. I'm a PhD research scholar from College of Agriculture, Bhubaneswar. I'm going to present topic on optimizing resources for enhancing farm productivity, the role of farmer-producer organization through a collective action. This is my presentation overview, the flow of presentation. Coming to the current Indian agrarian challenge, India covers almost 86% of small and marginal farmers, and which costs around 30 to 40% of input costs. Coming to the average land holding, in 1970 to 71, the average land holding was 2.28 hectares. When coming to 2020 to 21, it declined to 1.08%. A 53% of reduction is clearly visible here. And then cost of cultivation has risen 3x in two decades, while crop prices grew only 1.8x. Less than 6% of Indian farmers have access to the formal institutional credit, where 94% still remain for the institutional credit. To overcome this, FPO came into the game. What is this FPO and how it operates and what is its structure? FPOs are member-oriented farmer enterprises where the democratic governance through board of directors will be done and professional management by CEO, act as a specialized functional business units, which was supported by Small Farmers Agri-Business Consortium and promoted by NABARD, rural NGOs, state governments and CBBOs. This is the structure of FPOs, where the farmers itself act as shareholders, where they conduct a general body meeting, elect board of directors and CEO who take care of that marketing, input supply chain, value addition storage and custom hiring centers and mechanization. The policy framework for 10,000 FPO scheme. This scheme was initiated in 2020 to reach 10,000 FPOs. In 2025 February, we have reached 10,000 FPO scheme, where 30 lakh farmers are mobilized to join in FPO members, where 40% of them are women shareholders. Coming to the financial support, 18 lakh management costs were given to each FPO for 3 years. Each year cost 6 lakhs. And equity grant 2,000 rupees for a farmer and credit guarantee cover up to 2,000 crores. 5 years cluster-based business organization expect hand holding in 5 domains, like in marketing, financial management, training, technology adoption. What about FPO? What it will be done? Collective input procurement. We are seeing here the numbers. Around 18 to 31% of farm productivity were increased among FPO, where 14 to 60% annual income per acre was increased due to FPO membership, and absolute income growth was increased from 4,000 to 30,500 rupees, ranging upon cross and areas. And coming to the farm mechanization, collective farm mechanization helps the land preparation cost cut by 35 to 50%, which decreases the 700 to 1200 rupees per hour charges. Getting combine harvesters in a group has reduced from 8 to 10%, and labor saving from 2500 to 4000 rupees per acre. And getting sprinklers and drip sets utilized the water 40 to 50%, and the yield increased to 20 to 35%. Getting the threshers and cleaners has cut the loss from 5 to 8%, and grading improved their market. And drone sprayers, they saved 25 to 30% of cost and covered 7 to 10 acres. Approved. These drone sprayers were used for 25 pesticides according to DGCA. And combined paddy transplanter cut the labor cost by 60 to 70% and increase in yield by 8 to 12%. All this, these are the statistical data. And coming to the market linkages, this is a price realization index where for Kharif crops, if a non-FPO member gets 100 rupees, the FPO member is getting 107 rupees. For Rabi crop, if a non-FPO member is getting 100 rupees, the FPO member is getting 112 rupees. Coming to Kerala spices, FPO member is getting 145, and Punjab farmers are getting 118 rupees, and UP mango expert has given 125 rupees. Some of the key market integrations like ENAM, ONDC, direct institutional buyers, export linkages, where FPOs directly came into this game, and they have benefited a lot. For example, 22 lakh FPO transaction will happen to ENAM, and NAFED, FCI, Army Canteens, Reliance Fresh Foods, Big Basket has brought the farm food from directly FPOs. Export linkages, recently mango from UP and Andhra export to Dubai, and recently Odisha state also exported 51 kgs of fresh strawberries to UK from Denkanal FPOs. And second thing, agriculture value chain. Without FPO, the farmer's share of consumer price is 20 to 25%. For example, if a consumer gives 100 rupees, the non-FPO member is getting 20 to 25 rupees. For FPO, if the consumer is giving 100 rupees, then the FPO member is getting 45 to 65% rupees. Intermediate reduced from 4 to 6. Forward sale contracts eliminate distress. Graded produce commands 8 to 25% of premium, and post harvest losses was decreased to 5%. And FPO branding like Sahyadri, Amul has got premium response. Post harvest management, India is facing 92,651 crores of post harvesting losses, so that this FPO has decreased 12 to 20% of losses by primary processing, cold chain linkage, branding and packaging. Example is the case study of Sahyadri farms. Adoption of digital technology and advisory integration in FPOs. FPOs stand first in adoption of digital technology. AI crop advisory 22 lakh farmers reach, and ENAM 1361 mandis. In 1361 mandis, FPO members has enrolled, and AgriStack digital ID, precision remote sensing, drone surveillance and spray, and FPO data portal. And the main one, productivity and income impact. When we see the minimum crop productivity when joining FPO members are 18%, and the maximum productivity increase was for 31%. Coming to the income, minimum 14% income, and the maximum is 32%. Then the social capital and gender empowerment, we see 40% of women, 40% are women members in FPOs. By joining in FPO members, their decision making was changed from 22 to 61%. Their rural social safety net, youth agri entrepreneurship, collective advocacy and policy voice, and the climate resilient agriculture through FPOs collective action, India is facing a loss of 45,000 crores average annual climate related losses. So FPOs are the front line for their adoption, like drought tolerant varieties, micro irrigations, natural farmings, soil health and carbon farming, climate insurance, millet crop diversification. The key challenges and structural gaps in FPO scaling. There is a working capital deficit. Almost all 85% of FPOs are facing this. And governance accountability. Member attribution after 3 years, the retention of members was only 64%. And managerial capacity, the training of BODs and CEOs are enough or are not enough. The road ahead of policy and research priorities. The time to launch an FPO 2.0 as a business model, strengthening the financial architecture and CEO professionalization, digital infrastructure, climate smart FPOs, longitudinal research and MSME framework. The conclusion was the members and non-members, where the price was the consumer price was increased by joining in FPO members from 18 to 31%, and the value chain integration leads to post-harvest decreasing in post-harvest losses, and adoption of digital technology and climate smart technologies were the frontiers for FPOs. And the long-term research has evidence that there should be a market lead models and green FPO certification models, which leads to long sustainability for the FPOs. These are the some references. Thank you.
Thank you. Actually, the demerit with Indian situations is small holding.
Yes, sir.
But this FPO, that is a good approach. So that a large number of small holders, they can be combined and they can use AI for marketing purpose. That is a good use case possible. And thank you. So from audience, if something can be asked.
Actually, these are more statistical data. If I could have enough time, I could have explained each the statistical data. So,
No matter, you just analyze those and publish. Good thing, good example.
thank you. Thank you.
Thank you, Pawan. Now our next presenter is Anamika Patnaik, Research Scholar, OUAT. Please stick to the allotted time. Okay.
Good morning, respected chairpersons, honorable judges, and esteemed participants. I am Anamika Patnaik, here to present you on the biogenic synthesis of nanophosphorus for enhancing the summer rice. Rice is a staple food for nearly half of the global populations, and phosphorus is very essential for the development of the rice and other food crops. Phosphorus efficiency is very low. Conventional phosphorus fertilizers undergo salt fixation, and nano fertilizers can improve the nutrient availability and uptake. Commercially available nanophosphorus is costlier. Biogenic nanophosphorus has not been explored fully. Field validation of biogenic nanophosphorus is limited. The objectives were synthesis of nanophosphorus using microbial consortia, characterization of nano-P, and evaluation of nano-P on growth and yield of rice. The experimental methodology included phosphatic fertilizers are taken in 2 gram, 5 gram, and 10 gram per 100 ml, incubated with microbial consortia for 30 days under ambient conditions, and particles were characterized. The concentration were taken in 3 phases, and treatments combination is 12. The characterization of nanophosphorus is determined using dynamic light scattering analysis. The best treatment is rock phosphate 5 gram per 100 ml. The particle size was determined 168.9 nanometer. The graph shows the phosphorus source and the particle size. These are the graph of particle diameter of different rock phosphorus. The design was conducted in OUAT. The design is used to an RBD and treatment is 8 with application 3. Foliar nano phosphorus spray is 30 ml per liter at 15 and 30 days after transplanting. The effect on growth parameters. The maximum height was found to be 113.1 centimeter in treatment 8. Highest tiller density and also the maximum biomass was found in treatment 8. The treatment 8, we will find in yield attributes, the highest panicle is 292.7 meter per square. Highest field grain is 112.4. Longest panicle is 30.3. Test waste improved to 28.2 gram. Spikeless sterility reduces to 7.37%, showed better reproductive performance of rice. The next, the grain yield also increased from control 4.10 ton per hectare to treatment 8 4.915 ton per hectare. Even the nutrients, nitrogen, phosphorus, potassium also increased. In conclusion, biogenic synthesis from rock phosphate 5 gram per 100 ml successfully produced Nano P. Integration of SDVPR with Nano P improved growth yield of rice. Dual foliar spray at 30 ml per liter 15 and 30 days after transplanting enhanced nutrient uptake. Nano-enabled phosphorus management improves phosphorus use efficiency in rice. For future implication for food security, precision nutrient management through soil testing can optimize fertilizer use. AI-based smart agriculture and remote sensing support monitoring and decision making. Nanotechnology for resource use efficiency and contribute to sustainable food security. Thank you.
This is a good presentation, very nice slides, and also fluency was very good. So audience may please. Otherwise, I have one thing. Suppose your soil pH was 6.7. So what was the problem that at 6.7 pH soil phosphorus availability was low, so that it could respond to outside phosphorus? Because soil pH was 6.7, that is very optimum for soil availability of soil P. So what was the problem?
The soil gets fixed in the soil. Phosphorus gets fixed in the soil.
Phosphorus gets fixed in soil in which condition? When pH is high?
When pH is high.
And in rice case it is a water sufficient situation, pH is 6.7, so phosphorus availability should not be a problem. Okay.
Thank you, Anamika. Now our next presenter is Dr. Tanushree Sahu, Scientist, Fruit Science, ICR, IIHR, Chess.
A very good morning to the respected chair and co-chair of the session and esteemed dignitaries and audience. Today I am going to present on sensor-based soil moisture dynamics, a tool for precision horticulture. So under this topic, I am going to present a short study which I have carried out at IRI New Delhi during 2023. So soil moisture dynamics, it refers to the movement, distribution and availability of water in the soil over a period of time. So why we need to understand the soil moisture dynamics? it is a key factor which regulate the growth and yield of the plant, right? So as far as horticulture crop is concerned, it is very sensitive to different growth stages. Like there are different stages of crop which are sensitive to water stress. Even the excess of water is also harmful. So we have a role to enhance the water use efficiency through proper management of the water at the field level. And the soil moisture will also fluctuate due to different processes like your rainfall, irrigation, evapotranspiration, and infiltration, percolation, and various processes. So monitoring these changes are very much essential in terms of precision agriculture and climate resilient farming. So basically in my study I have there are two methods of soil moisture estimation. One is direct method and another is indirect method. So the standard method, that is gravimetric method, is the direct one, and all other, that is your tensiometer, gypsum block, capacitance sensors, and time domain reflectometry, that is TDR. These are the indirect methods of soil moisture estimation. So I have taken the standard one along with the two sensors, that is tensiometer and TDR method. So basically we did this research in order to find the reliability of the data that is obtained through the sensors. These are the three major objectives of my study. First one, to measure the soil water content through the standard method, that is gravimetric method. Second one, to measure the soil moisture content through tensiometer and TDR. And third one is to compare both the data. So these are the methodology we followed, and the experimental side, as I told, it is at IRI. So the climate of Delhi, it is categorized as a semi-arid climate, and the observations were taken from the experiment at the PFDC experimental plot where onion was taken as the crop. So this is the table showing the weather parameters recorded during the period of experimentation. I am not going into the detail. And this is the physical properties of the soil of the experimental field. This is the experimental setup where we have taken the Bhima dark red onion, which is the late Kharif variety. So that is having very good potential. So this we have taken tensiometer installation at the field, you can see here. So first table, it is showing the comparison of soil moisture through gravimetric and TDR method. So there are different dates, and you can see this is on the volume basis. So gravimetric moisture, it is showing the readings, you can see, and on the second table you can see the TDR readings. So for some readings it is showing the similar one, but for some reading it is showing the very high fluctuation. Like for the date 11, it is showing very high fluctuation, so that is non-reliable. This is the table in continuation, and this is the graph which is also showing the comparison between the gravimetric and TDR measurement. So from this graph also you can see there is, for some dates there is a large fluctuation between, this particular observation I have taken physically, like I used to collect the soil samples on the particular date, and I used to estimate the soil moisture followed by the standard method. Along with, on the same date, I used to take the reading on the TDR sensor also. So you can see there is some fluctuation. So we cannot blindly rely on the sensor data. It needs some calibration before use. So this is the comparison between gravimetric and tensiometer method. This is, from this graph you can see almost at par. Okay, like for majority of the dates the readings are at par, but for some dates there is little fluctuation is there. So this is the irrigation dates with MAD value. MAD is the maximum allowable deficit. This is different for different crop. For onion it is 70%. So that means the MAD value should not go below the 70%. So you can see from the table, for some dates it is less than 70, but majority of the cases it is above 70. So it is perfectly fine. That means the crop will not be affected. So inference we can draw here that irrigation scheduling is actually based on the experience of the farmers, but yeah, when experience comes into point, sometimes there is a possibility to over irrigate or to under irrigate. As far as onion crop is concerned, the transplanting stage and the bulb development stage, these are very, very critical for the water stress. For those stages we have to be very much alert not to impose any kind of stress to the plant, otherwise the yield will be severely affected. So from the short term study I have conducted at IRI New Delhi, it is done that it has been observed that the irrigation was below MAD for onion in some cases, but for most of the cases it is above 70%. And the field capacity of the soil in onion field is 26%. So the soil moisture should not go below 18.2%. That means 18.2% is the 70% of the field capacity. So the moisture content should not go below that. And the conclusion we can draw here is the use of sensors is actually needs a careful installation and monitoring in order to obtain the reliable data over a period of time. That means we cannot blindly, take observations through any kind of sensor. As far as soil moisture sensors are concerned, we cannot blindly rely on the data. So it needs some calibration each time before the use in the field. Okay, because from this practical experience, we are clearly concluding that it is showing some fluctuations. So calibration is needed, and through proper use of sensors, we can definitely do the irrigation scheduling part. Thank you, sir. Thank you so much.
So, request from the audience, if some question.
Maximum allowable deficit. That is not maximum. That is management allowable deficit. You are changing the notation. You are changing because it is diluting. The purpose is because it is already been standardized by many researchers. Thank you. It's a good study. Please correct.
So correct, sir has correctly told that is a manageable allowable limit, deficit limit. So that is one thing. The second thing that so we should not rely blindly on the sensors. That is very correct because they give you very fluctuating results because they are measuring the voltage. So from voltage they are converting to volumetric moisture content. That is an indirect way of measurement. So always we should have that. But then why TDR is a costly instrument? 12 lakh now it is perhaps 14 lakh one instrument. And if this is soil moisture sensor that tensiometer, you use tensiometer, and tensiometer is giving good result, then why this TDR is being used?
So TDR is portable and easy to use. You can take it to any kind of field. Tensiometer you can at a particular location you have to install it. So TDR is relatively easy to use. It is as far as use is concerned, you can take from one field to other field. You can easily monitor. But thing is that before the TDR sensor data, we have to calibrate it. Like the sir who has given me the task, he has told me like you have to take the reading in wet soil, in dry soil, like that. You have to do that. Sir, sorry, sir.
TDR, you need to have the access tube installed. Without that, cannot use it.
No, without that we can't use it.
So, like you are saying, anywhere you can use TDR. You need to install prior to that the access tube.
Yes.
So, what is your comparison with the gravimetric?
Gravimetric versus sensor data, sir. Sensor we have taken to TDR and tensiometers.
Okay. Yes. Tensiometer has limitation. Range limitation with TDR doesn't have. So in that same range, okay. Tensiometer is easier. Otherwise, TDR to have the access to install. Gravimetric can substitute, but we can't have gravimetric.
But gravimetric all the time we can't use.
It takes time, you'll go to the
Yes.
lab.
Time consuming.
Okay, thank you.
Thank you.
Good work.
Thank you.
Because your crop was onion. Onion is a very shallow rooted crop. So that way tensiometer could work well, and also IRI soil, that is a light textured soil. So that way, but if the soil texture is different and the crop is different, suppose a deep rooted crop, then TDR this tensiometer may not work. So that way that is useful.
Yes. Thank you, sir.
Thank you, ma'am. Now, the last presenter for this session is Dr. Ashok Kumar Naik, Principal Scientist, ICR, IIWF.
Dr. Ashok Kumar Naik will be little late in reaching, and I will be presenting on his behalf. Actually, the work is on canal automation. So that work was carried out in Ratnaranpur minor irrigation project for automating So Ratnaranpur area, and this is basically a initial work, and the technology is not finalized yet, but the concept is that this minor irrigation project, there is a reservoir, and what is the volume of water present in that reservoir, because that water gauge is there in that area, so depth is known and the area is known, so volume is decided. Then according to that volume of water, what will be the crop plan, which crops we will take in Rabi. In Kharif usually it is rice, but in Rabi season what crop we should take, light duty crops, and accordingly how much water will be released, that is decided based on the decision support system. And actually theoretically it is very sound, but in practice there are several problems, but still there are some benefits. Suppose how much water will be released from the reservoir. If we open as per our routine practice, a huge amount of water will be released. But here in this case, the gate will be open as per our instructions. Suppose the potential height increase is about 50 centimeter, and we are thinking that this is a light duty crop, and it will require less amount of water. The flow of water in the canal should be slow. So accordingly, we will lift the gate of the canal to 30 centimeters. So we will have 20 centimeters. Then we will instruct that open the gate up to 20 centimeters only. So from Bhubaneswar, we could give instruction, and accordingly the canal, that gate, that could be open only up to 20 centimeters. That is now in a demonstration stage. We are demonstrating to our visitors, to our water resource department. Honestly, it is not in fully operational stage, and we are trying. Thank you.
Thank you, sir. If there is any question, we will move forward. Thank you, sir. Now we will be having 2 minutes discussion. If anyone is having any questions regarding the previous slides, anything they are free to ask. Any questions regarding the previous slides or anything from this session, you are free to ask.
So we couldn't take a question from G. Pramila. She is here. Okay, if any question for her also, you can ask.
Yes, for any presentations, if you have any questions, you can ask. Yes, yes. All of it.
I have some questions. So you presented a few statistics getting please tell the source of those data which you have presented. So
actually you have mentioned there the level of increase in income and minimum income they are getting after joining FPOs. Then how will you compare them? Do you use any statistical software or tool, or it is just a summary statistic? Okay. Please tell your sources of your data. Okay. Okay. Data minutes. NABARD annual financial statements. Okay, so it's all combined data, or you particularly taken a particular state or area or what?
You both can use the same mic. You both are nearer to each other, you can use the same mic.
So this is the secondary data consolidated from NABARD, small farmers business and managed institutions, state government departments, and press information of India (PID), and the Central Warehouse Regulatory Authority, and export import, ENAM. These are some institutions I have taken the data, sir. Thank you, sir.
Anyone else? Any question? If not, I have a question to Rautra sir. Sir, your slide was excellently presented. It was very useful. So one of your slides you showed an example of cotton bollworm where pheromone was incorporated along with AI. So my question is, can we predict it for the entire district of state using that, or it is only predicted for a specific plot?
Yeah, it is predicted for a specific region, usually in a block level, and also if a block is predicted, then we can also assume that for that district also. Actually, that is a success case. So in 2025, they could manage cotton bollworm through this technology, and the Punjab government, they have requested for all districts. So all cotton moving districts. So usually at a district level.
So in that case, how many pheromone traps are used? Is it the data collected from one or two, or it has been?
The number is more, the basis is more. But it is also, we have to see also economics. At least in some districts, 3, 4 or 5 such units are established, and that data is known. Then we can know that cotton bollworm is approaching early this year, so that we can take preventive measures.
Thank you, sir.
Because it is all depends upon the environment and the situation. So environment is almost nearby, similar.
Yes. So since we do not have any more questions, we will be moving forward to the closing session. Now I will request Dr. R.K. Panda sir, the chairman of the symposium, to please come over the stage and felicitate the chairman and co-chairman. So please.
because I meant own teacher.
Now it's time to felicitate our co-chair. Thank you, sir. With this, we come to the end of session 1 of the symposium. Now, for this session 1, I would sincerely like to thank our chairman and co-chairman, the keynote speaker, presenters, and the participants for making this session a innovative and engaging one. Thank you. Now we have tea outside. The session will continue. Anyone who want to have tea can have it outside. And I would request Dr. Devasya Sota to continue its session.
Good afternoon, everyone. Since we are running out of the time for the tea break, and as we are running out of time, so we have to continue the session as fast as possible. So we should start. And after the ending of the session, marvelous session of the session 1, about all this AI related in agriculture, and we will start our next session for the day, with session 2. And in the session 2, I would like to invite our chairman and the co-chairman. The chairman, Professor Basudev Behrasau, Professor and Head Agronomy, Faculty of Agricultural Science, SOA, and the co-chairman, Professor Ramachandra Das, Professor Agricultural Engineering, Faculty of Agricultural Science, SOA. So I would like to be in the stage, sir, and please take your seat, sir. So on that aspect, when the chairman and the co-chairman is taking the seat, I would like the volunteers to do the necessary arrangements while the chairman and the co-chairman is taking their seats. Along with it, I would like to introduce our rapporteurs of this session, Dr. Sweta Datta, Assistant Professor Agronomy, Faculty of Agricultural Science, SOA, and Ms. Swati Sucharita, Research Scholar, Faculty of Agricultural Science, to be in the stage so that they can have their all the necessary day. They will go for the rapporteurs, and they will go for the noting all over the session. Apart from this, I will request the chairman and the co-chairman, sir, so that one of the best oral presentation we could have from this session. So it is the request so that we can finish all the oral presentation as early as possible in the right time. So for every oral presentation, we will have a 3 + 1 minutes, 3 minutes for the presentation, 1 minute for the question and answering part. So that we should limit to our timings. And before I will start about all these things to the session, the first, it is the keynote lecture. And the keynote lecturer, it is a privilege for me. So if the livelihood alternative, it is our part of this this agriculture fraternity, and we are all having we having the MOUs, and we are internally and externally we are already coordinated with the livelihood alternative LA. So once upon a time, Sri Sambit Tripathi sir, he has introduced me in one lecture, and it is a privilege for me that I am introducing him in this symposium for this keynote lecture. So I request Dr. Sri Sambit Tripathi sir, the CMD of Livelihood Alternative, for his talk in the topic AI in Agriculture, Opportunities and Possibilities. I would request sir, please welcome to the stage so that we will have your lecture, sir. Thank you, sir.
Namaskar. Respected chair and co-chair, Professor Panda sitting in front in the audience, Professor Suva and my senior teachers who are here. I was just just telling Professor Subhapada that I am actually not a student of agriculture, and I belong to social science background. So when I was listening to all these scientific presentations, so I was wondering what exactly I should speak on. But I decided I'll speak on a few things with which I am associated, and that is the startup ecosystem. In fact, as part of IRMA IC Foundation, this is the Institute of Rural Management Anand, there is an incubator called IRMA IC Foundation. I am part of that. And they are into mentoring lot of startups who are working in the field of agriculture, especially in the field of artificial intelligence. Because you know that artificial intelligence is something which is smart agriculture, which is technology-led agriculture, and it is the youth of India, especially from various scientific and technical institutes, who are engaged in creating solutions, everyday solutions for farmers, for agronomists who are faced with various challenges. And if you look at the first challenge and the most important challenge today, that is climate change. It is estimated that there will be impact of 1 to 2% reduction in our GDP because of climate-induced changes which are taking place across the world, and India is not immune to that. That is number one, and that is why we have to prepare ourselves for a better tomorrow, where we are in a position to negotiate and engage with climate-related disturbances, climate-related disruptions, which is already there. And if you look at the solution, probably the best solution that we can provide for is artificial intelligence. Today, there is a lot of talk on artificial intelligence, and unfortunately, the whole question of artificial intelligence today is negatively framed. We are talking about disruption, job losses to artificial intelligence. But every technology has its own positive sides as well. And the most important part of artificial intelligence is to provide us with solutions by which the farmers in India can negotiate the climate crisis, which is very much there on the horizon. And if you look at the various value chains, starting from the soil management, water management, including to the market linkages. In fact, one of my friends was talking about FPO. The very purpose of creating FPOs, the farmer producer companies or organizations, has been to enhance the income of the farmers. And without a proper market linkage, probably that is not a possibility. This is where the artificial intelligence, the technology, which are coming to the aid and assistance of all the farmers and also policymakers. Now the question is, what is artificial intelligence? In fact, artificial intelligence is actually a convergence of various technologies that we are looking at today. So you have Internet of Things, which is popularly known as IoT, you have sensors, you have data analytics, so you have robotics. So it is all convergence of various technologies. Data analytics, which is giving us the computing power. So it is giving individuals, humanity, scientists, policymakers to create, and innovators, especially the innovators, to create such technologies which will not only supplement but also complement human intelligence. So whatever was not possible earlier to share human intelligence can happen now with artificial intelligence. So let me first talk about the market part. Now, if you look at various startup ecosystems which are working, there are a few startups. rises. So these are the warning signs for farmers. So if they get predictive and reliable information about all these activities, probably the crop yield will be protected, and finally what they get are better realization for their crops. Another important aspect where the startups are working in is in terms of post-harvest loss. Post-harvest loss. As you all know that in India, the post-harvest loss is a very important component, and it also contributes to the loss that the farmers they are incurring today. There are a few startups which are working on this, where they are able to understand why this, like when the crop is stored in a godown or it is stored in a warehouse. So what are the factors? Like there are pest infestation, there are rats, there are other activities because of moisture difference in that particular area. There might be some problem. So these are all predictions, and they give reliable predictions by which you can actually cut down the waste. This is where artificial intelligence helps. Recently, as you all know, India has become the #1 country in rice production. We have produced 150 million tons of rice. We have surpassed China. 3 days back, I was reading an article in Indian Express which talks about how the cultivation of rice, and we are also one of the largest exporters of rice. We are exporting around 21 million tons of rice, and our second competitor is Thailand, which only exports 7 million tons of rice. But that is another sustainable aspect which is associated with it. And that aspect is about we are also exporting water. For each acre of rice cultivation, since a lot of scientists are here, that is what the article says, we use around 1 lakh liters. So every 1 kg of rice that we are producing, rice grain that we are producing, we are actually exporting 2,000 liters of water with 1 kg of rice that we are exporting. Now, this is something which is quite important to manage. We cannot say that we will not export, because it is also connected with the farmer's income. It is connected with the global commodity supply chain. So it is here that I found that a lot of AIs, in fact, in 2023 in SOA itself, we had organized a startup conference where we had called various startups who are working in this agri sector, and we had also had called farmers. So there were 2 startups which were there. One was Barryflow, another was EF Polymers. EF Polymers is a Rajasthan-based startup, and Barryflow, I think, is from UP. So they have created a kind of an instrument which will predict the optimum amount of water that needs to be there in the rice field, the paddy field. So that is how they are reducing water consumption, and they are contributing to sustainability of agri produce. So that is what they do with IoT, with sensors, and that is where the artificial intelligence plays an important role. One of my previous speakers was talking about soil health. All of us know that soil degradation is a real challenge in India, and the generation of soil health cards, which has been a government scheme, also faces its own challenges. Yesterday, there was a young boy who had come. His name is Ronak Manda, Nodia boy. He is creating a feedstock plant for animals in Baleswar. And he has also created a device. In fact, I think he has borrowed it from IIT Kanpur and IIT Ropar. I was telling Panda sir about the instruments which are coming up, very cost effective. He showed me one instrument yesterday. It was just 10,000 rupees, and it is connected with an app. And it can give the NPK and the organic content, the moisture content of the soil within 90 seconds. So these are the innovations and the technologies which are coming into the Indian ecosystem, agricultural ecosystem. And it is important that today we leverage such AI-based tools, AI-based instruments for augmenting agricultural production, not only augmenting agricultural production, but also to mitigate the climate risks. There's another, before I conclude, I'll talk about one such experiment, and that is we are doing in Satyavadi. In fact, our friends from SOA also, they have gone and visited. There is this startup called Embryonics from Nagpur-based startup. So he has come up with a substitute, a low-cost substitute for polyhouses. He uses the root temperature, manipulates the root temperature. They're like pod-like structure, and he is able to help farmers grow vegetables and other crops, floriculture, vegetables especially,
under very high stress condition, 40-45 degrees temperature. And if the polyhouses typically cost around 70 lakhs per acre, the cost comes down to 4 lakhs per acre. And he uses, even sitting in Nagpur, he can tell about the various activities, the crop yields, and the trends in cultivation through a simple app that he has installed. So these are the new innovations which are coming into the field. These are very exciting times, but unfortunately in Odisha it is taking time for us to adapt to such new technologies. Maybe because we have very small land holdings, and small land holdings in agriculture becomes unsustainable practice. But as the time goes, and especially if the young people, there is another trend in Odisha where the young men they migrate out, and maybe at 35-40 they come back and they start agricultural activities. But adoption of those technologies becomes very difficult at that point of time. So our understanding of Odisha's agro ecosystem is that the young people are there, adoption of technology is very easy, and it becomes a very remunerative exercise or engagement for people at the grassroots. And that is where probably the scientists, professors, students, teachers, and all the people who are working in this ecosystem can play a very vital role. Thank you.
Sir, the nutrient sensors for estimating the ALPK content, that is not working perfectly. Actually, the sensors we are claiming for nutrients, but at present, our sensors which have been developed is not so perfect. Soil moisture sensor, to some extent it is okay, but nutrient sensors is not so in field situation, whether it is working well.
Sir, that is what in fact we were discussing before. I was mentioning that to sir and Subha sir. So I was telling since he has come, let us do 2 sample surveys. We'll do through the traditional method as is happening in the lab. So we can get the results through that. And the second part is through the new one that he is telling. So we can actually compare whether they are reflecting the same results or there are some deviations in both the things. So then only because you will find that in this sector, because I am not, as I said, I am not a scientist, but what I have seen with my interaction with various people, there are various such devices which are there in the market today. So you have IIT Kanpur, I think something they have developed, IIT Mumbai they have developed, and they are now getting slowly commercialized. And this guy who came yesterday, he has come from IIT Rupert. So that is the instrument that he brings. So and that's what Subha sir was telling, that they are not giving the right picture. They are not, the data is not reliable. So we can do a sample where we can do the lab test, and the same sample can be subjected to the test through the new instrument, and probably then only we can, that's my understanding.
Actually, soil moisture sensor, we take the cutoff range of 4%. If it is the acceptable, accuracy level is within 4%, we accept it. So I'm not an agriculturist, I don't know about the NPK or at least nitrogen. I don't know, maybe 4-5% accuracy level, if it is compromised, we can accept. So we can, validate that, test it. So that would be a good thing. We had discussion if it comes. At least it saves time. It takes time to go to the lab and analyze, so that would save significant time.
Sir, another thing also in connection with this soil test, I would like to say that soil test is from whom? It is for the farmers. And at many times, 90% of the time, they will not understand what is NPK and what is its implication in terms of fertilizer usage. So it is also important that once we test the soil, we also have camps or we have an outreach program. We explain to them that this is your chemical composition and this is what you are doing, this has been your agronomic practice. and you have to change in terms of this. So that probably will bring down the cost of cultivation also, and also will help in safeguarding the soil health. So small experiment we are doing in SOA in this, in both. We are not only testing the soil, but also we are bringing the farmers here to this campus and explaining to them, this is your soil health card, and these are the test results, and you should change your practices, agronomic practices in this manner.
Ji. Good morning. So today you talked about a startup called Fasal, which had developed a application which provides online information regarding agriculture. Is that application available readily, easily for farmers, and is it in the form of a mobile application as well?
See, this is the form of registration. In fact, when I came, we were just having a discussion with them, and they are doing it only for horticulture crops. They are doing it for oranges. They are saying that it's more reliable for oranges. So we are going to experiment with Fasal. There is this block called Riyamal in Devgarh district, where there are orange farmers. So we will put up a weather station, and the weather station will capture what they are saying, that the weather related, atmospheric related data on a real time basis, and it will transmit it to their center in Bangalore. So on the basis of historical data and the real time data that they get, they will generate advisories, and those advisories will be the farmer will have an app installed in his mobile, and it will come to the farmers. But this is we are at this level. It is available. It's not that you Google Fasal, you will see that it's a Bangalore-based startup. They are already providing these services. I think they will charge around 30,000-40,000 rupees they're charging right now. And we are putting up this we are in discussion to put up this in Riyama.
Thank you, sir. Any further question? Okay.
Thank you. Thank you, sir.
Thank you, sir. So it was a really very brainstorming session, and sir, as mentioned that AI it is not get your job. Rather, AI can be used for a tool purpose. It is a true sense we can use the AI as a tool for the job security as well. Okay. Before I will go to the next keynote lecturer, I just want to announce that Dr. Poonampreet Pradhan and as well as Dr. Pradosh Kumar Parida. If you have your slides, please submit it at the backstage so that we can start the next session. And as right now, as said that sir has another job to continue. So I would like to felicitate Sri Samrit Tripathi sir in the stage. So I would like to again invite Dr. R.K. Panda sir to be the chairman of this symposium. So be in the stage, sir, so that we can go for the felicitation program. Please come to the stage, sir. And I also invite our chairman, sir, and the co-chairman, sir, to join this session. So the felicitation program, it will be a grand success, and I wish this symposium, in terms of symposium, it will be a great success. So. That's his greatness, sir. He is always available with us. He is the real man, sir, who is working behind this in the ground level, sir. So we should continue our session 2, and the second keynote lecture. It is all about this AI-enabled rice agronomy for facing the 21st century challenges. And this is given by our chairman, sir, Professor Basudev Behra, sir. He is professor and head in the agronomy of Department of Agronomy, Faculty of Agricultural Science. So I would welcome, sir, for the lecture, sir.
Good afternoon, all present in this international symposium. Our Director of Center of Climate Smart Agriculture, Dr. R.K. Pandasa, all the heads of the department, all the delegates and participants, our co-chairman and rapporteurs of the session. So I will be discussing about AI-enabled rice agronomy for facing 21st century challenges. So rice crop faces number of challenges during this 21st century, and rice is facing difficulties in facing those challenges. And AI has come as a panacea for solving all these problems. So for that, what is AI? So artificial intelligence, the branch of computer science, it creates machines and computer systems that can perform tasks requiring human intelligence. Just it works just like a human being. We can tell just a superhuman or superman. So briefly we can tell it is science of making machines intelligent. So as we go on to the history of this development of AI, formally it was established in 1956 at the conference of Dartmouth College in Hanover in New Hampshire, USA. But AI foundations developed during 1950s, that is mid 20th century. But there are many ups and downs. Many people thought AI will damage the world, and also sometimes many argued that it will save the world. So there are many ups and downs, and finally after 1990, that is in the last part of the 20th century, AI again emerged as a major event. So the AI divisions, if you consider, there are several divisions, particularly machine learning. It enables computers to learn from data and improve performance automatically. Another is natural language processing, or NLP. It allows machines to understand and generate human language. Computer vision, it helps to interpret and analyze images and videos. And robotics combines AI with machines to create intelligent robots that can perform physical tasks. And expert systems, that are computer patterns or systems that mimic the decision-making ability of human experts. And speech recognition, it also enables computers to recognize and process human speech also. So these are how different AI are related to each other. So AI, if it is said, we can tell machine learning is a subset, and deep learning and several other components like natural language processing, robotics, and autonomous vehicles, and computer vision, all are the parts linked to the machine learning. The core approaches, there are three core approaches. There is symbolic AI, that mostly it depends knowledge in form of explicit rules and logic. And machine learning, it derives patterns from data enabling adaptive performance. And the deep learning is based on several artificial neural networks. These are three important approaches, and sometimes we use the combination of any two or three, that is called hybrid approaches. So it will come to how AI will save the rice crop, or how we face what are the challenges to rice, how the rice will face those challenges. So the algorithmic rice agronomy, it is a term how will rewiring the rice plant, how will integrate the soil, climate, and different phases of rice plant, starting from the different growth phases
how they interact with the climate, how they interact with the soil. So all these things can be possible by step, orderly steps of the AI. AI at the end-to-end transformation of all the crop life cycle. You will consider rice agronomy. Rice agronomy, mostly it includes the land preparation and tillage, nutrient management, water management, wood management, and the post-harvest the harvesting systems. So particularly, these are the important aspects of the rice life cycle. So how AI will transform, how this AI will protect rice crop from different problems facing in the 21st century. The essential threats to modern rice cultivation, mostly climate and weather. Climate variability is the most important challenge for the rice, particularly global warming and the irregular weather events like drought, flood, salinity, cyclone, the untimely rainfall during maturity of the crop. So these are the weather events, and the environmental degradation. These are also very important soil degradation, environmental degradation. Then different operational stress, particularly labor scarcity, the hiking labor wages. These are the important problems. And biological pressures, particularly weed, disease, and insect pests. These are the biological pressures that are putting a high pressure on the rice crop. So coming this artificial intelligence, it moves from screen to the soil. Particularly the artificial intelligence, the shift and the core capability because of different parts or different aspects of artificial intelligence that helps in particularly from computer screen, how it will operate and move to soil, and also integrates all the parameters of soil, climate, and ultimately can solve the problems that are faced by rice. So AI agronomy maps the specific technology to core farming operations, particularly machine learning that we can tell as the brain. Just like human beings, also machine learning acts as a brain, and a computer vision, this acts as eyes of the eyes, and robots, these are real muscles by which the work can be executed. And IoT sensors, they can collect data from soil, by also from climatic data, and how they will integrate. So in this way, the brain, eyes, muscles, and the senses of just like human beings, they can all these can solve the problem faced by rice crop. Drones and unmanned air vehicles that deliver real-time aerial intelligence for targeted intervention. Particularly advantage, they can take real-time images, they diagnose the real-time threats in respect of nutrient deficiency, in respect of wood menace, in respect of disease and insect pest attack, and finally they provide real solutions. And deep learning engines power complex agronomic patterns. There are deep learning patterns, particularly deep learning techniques. These are several neural networks, these are artificial neural networks, then CNN, then RNN, GAN, and autoencoders. These are several the neural networks which act on the brain or the real that helps in the execution of various machine learning practices. What are the challenges to in the 21st century for tillage? Tillage, rice is a tillage intensive crop, and tillage is a nuisance. Totally excess tillage deteriorates soil structure. Particularly the crop structure which is essential for soil, that is deteriorated. Similarly, many problems, particularly time planting of the crops, that is very important, and also residue management, labor scarcity, and soil health degradation. organic carbon will decrease. There are various problems faced in context of tillage. And smart soil preparation eliminates compaction and protects soil health. So several scientists work on these aspects, particularly the podding, that high intensity tillage that makes the soil, turns soil into a puddle. The soil structure is fragmented, that is deteriorated, and that soil structure built up is required. So particularly the variable depth tillage very much important. So accordingly, the AI solutions are available so that variable depth tillage or the whatever tillage requirement, accordingly to the requirement, the tillage can be performed. So some workers have worked on that. The 21st century challenges in particular water management. In water management, the irrigating in real time, that is very important, because crop faces sometimes stress, sometimes excess water stress, sometimes the deficit water stress. So real time water management is very important. Due to excess water, sometimes over irrigation, that causes nitrate leaching, that causes flooding. So also in the rice, particularly standing water there is a problem of greenhouse, particularly methane emission. So several problems are there. So there is a need to address all the challenges. So automated wetting and drying, the alternated wetting and drying system, that is very essential for rice cultivation, because rice due to continuous submergence creates several problems. There is methane emission problem, leaching of nutrients, and destruction of soil structure. So many problems are there. So alternate wetting drying, that is a very essential solution for creating or for avoiding all these problems. So accordingly, the solutions are there. Particularly, there are sensors which can measure or sense the depth of water, and accordingly, the CNN sensors are there, or the neural network or deep learning systems are processing by that that information by that the automated water pump system that works. So accordingly, the collection of the real-time data and processing data and informing the pump whether to keep it on or off, so that the real time in real time we can provide irrigation. So this is very interesting system. Last speaker, Mr. Tripathi, he told how 1 kilogram of rice equals 2,000 liters of water. That is called virtual water, where exporting, and water the reduction of this water demand in rice, that is very important. To economize water is very important. So this AI has come as a panacea for solving all the problems related to water management. So intelligent systems caught irrigation that reduces water requirement by 25%. And Zhang and his workers, co-workers in 2025, they worked on intelligent precision irrigation control system, that is IPICS impact. How what are the advantages of this system? In this system, there is particularly irrigation water saving, or the reduces water requirement by 25%, 3%, and nitrate leaching, which is a very important or very loss in particular rice soils. There is a reduction in nitrogen leaching by 57.4%. And the water use, the essential water productivity, that increases by 31.8%. So different predictive models have been tried, like artificial neural network, random forest, decision trees. So this artificial neural network that provides very high precision in water management. 21st century challenges, particularly in new tenure management. In new tenure management, due to excess use of chemical fertilizers, particularly, and we are avoiding use of organics. Due to continuous use of chemical fertilizers, particularly nutrient deficit and toxicity are becoming a problem. People are using mostly urea, nitrogen fertilizers, and ignoring other fertilizers. So there is deficiency, particularly sulfur deficiency problems are coming, zinc deficiency problems coming in the rice. So nutrient deficiency problems are there, and particular decline in the particular many types of organic matter content, and also several problems are there related to nutrient management. So all these problems can be addressed by the precision advisories that replace blanket fertilizer application. So far, we are applying blanket fertilizer application. That is recommended dose of fertilizer application. The recommended dose of fertilizer application mostly that is a fixed dose. So that based on salt test, that is general for a particular state or for the whole country doses are there. But each field requires the specific fertilizer dose. So the large big data set that collected from a particular field can be analyzed, and real-time requirement of the fertilizer can be determined. Accordingly, nutrient can be applied. So in that, particularly the drones, they take real-time images, and by analyzing the chlorophyll content or color or by image, the real-time nutrient requirement and nitrogen requirement can be estimated, and immediately the nutrient requirement can be fulfilled. Similar 21st century challenges in weed management. Weed management in rice crop, because of it is grown over a different diverse ecosystem. It faces a diverse weed flora. Brown leaf weeds, narrow leaf weeds, or the grasses, sedges, several weed flora. Particularly new weeds are also emerging, particularly the amaranthus species, and several new species are coming. New weeds are coming to the rice field. Then also wood shift is a major problem. Whatever weeds were predominant once upon a time, now new weeds which were not predominant, now they are becoming predominant. So wood shift is a problem. Similarly, the chemical, because we are relying mostly on chemical herbicides, that is a health concern, is a major problem. So what are the solutions for these problems in rice, particularly with respect to weed management? So deep learning algorithms, particularly different crops from weeds in real time. Rice is a crop which is a monogamic crop, and several weeds they mimic rice, like suppose a soma or the Echinoclea colonna and wild rice. These are two weeds which are very much similar to rice. It is very difficult to differentiate. Even human beings cannot distinguish rice and these weeds. So nowadays, by satellite imagery or by different AI technology, we can easily differentiate crop, particular rice and weeds, and very precisely and very effectively we can control the weeds, and particularly what herbicides can be are recommended, and for that weed particularly that can be applied and weed can be controlled. So Rosley and Islam and their co-workers, they worked on these lines. Similarly, automated robotics, because this is work done under our particular SWADU, Bhubaneswar, and Mahanti, and also Subhaprad Das was involved. And they have also worked on this robotics. In this robotics, they have achieved about 95% efficiency in weed control by identifying the real weeds and applying the herbicides, and also about high efficiency with respect to weed incubation, both weed control and weed incubation. These have been achieved by these robotic systems. So there is a 95%, up to 95% is a high weed control efficiency that is achieved by these robots. Similarly, hybrid algorithms detect disease and pest outbreaks before they spread. So many insect pests like swarming caterpillar, brown plant hopper, they cause havoc in rice field. So real-time detection, how to predict the occurrence of such harmful insect pests. That's very important. And they are equally in real time and before time we can diagnose or we can predict and control measures can be taken and so that the problems of farmers can be addressed. So now the IoT can collect weather data. They can take whatever the humidity, whatever the moisture or whatever data, atmospheric data, and accordingly multi-stage also the various imagery, and they can analyze and the real-time decision support can be provided. Similarly, advanced optimization algorithms accurately predict and classify rice diseases. Particularly, the artificial neural network, this system that can help, and also the hybrid approach. There are one is the APSO system, and also WOA, well optimization algorithm. The hybrid system, when two systems or two approaches can combine and hybrid system can be taken, they can effectively diagnose or predict the rice diseases. Then challenges to in rice with respect to harvesting and post-harvesting management. Particularly in rice, if you delay the rice harvest, there are many problems. Particularly shattering loss and many problems are there, and also sometimes on-time rainfall is there during harvest time that causes vivipar germination, and excess moisture leads to grain deterioration. So timely harvest is very important. So judging time of maturity and also predicting the weather situation so that advanced harvesting can be done. Particularly rice can be harvested at physiological maturity stage. Before harvest maturity, we can harvest it at physiological maturity if weather requires so. If that can be predicted that a bad weather is coming, then rice can be harvested before the harvest maturity stage. So this is possible by predictive analysis that mitigate threat of the market post-harvest loss. So there's a prediction can be possible. So real the agronomy, the return for investment. These are required from rice crop. You will get more return. How if you will take these AI tools, particularly for land preparation, there is a problem of compaction, and if you will have variable depth tillage, then that the soil health can be conserved. Similarly, with respect to water, flooding is a problem, over irrigation is a problem. So the automated alternate wetting drying, that is a solution, and 25% water can be saved. Similarly, new things, particular blanket application or the recommended dose application, that is a common rule, but AIoT drones that can predict or we can have zero nutrient loss that can be achieved. Similarly, with respect to crop protection, blanket spraying is recommended, but YO version 5 robotics that can have 25% wood eradication. Similarly, harvest, the post-harvest loss is very common, and predicting real-time prediction of the timing of harvest that can also mitigate crop loss. So by that we can get a high return from rice. So several ethical issues there, particularly there is need for bias in sometimes AI, there is biasness also. There is need to avoid those biasness and alignment with the human values. How they should be matched with human values. The need for human AI collaboration. So AI and human beings, that is collaboration between them in governance, in also responsible development, that is very much required. AI is a multidisciplinary pursuit which requires computer science, mathematics, linguistics, philosophy, also neuroscience. Similarly, nowadays various challenges are there for this AI in rice farming, but there are challenges in the employment. That increases manpower requirement, algorithm fairness, all the step by step, all the order or the whatever algorithm developed that should be very much there. Then data collection, data ownership, data privacy, that is a challenge. Huge cost of implementing AI-based setup, that is highly costly, particularly in rural areas where the rice fields are located. These are challenging. Limited digital infrastructure, affordability, digital literacy gap. Particularly, many people are also not literate with respect to AI. So, particularly low resource agriculture farm setup in the rural areas. So, this is gap. So, particularly these bottlenecks, there is the vast potential for AI. AI is the solution for future challenges in rice, particularly in 21st century. And there is also current widespread adoption also. So there is a potentiality, there is a need also. But what is the gap between this potential and need? There are several necks in the bottom, particularly data scarcity, digital infrastructure, economic feasibility. These are various necks or the conflicted areas which should be addressed for large scale adoption of AI in rice. Particularly the infrastructure and affordability remains primary barriers for scaling up. Particularly data governance, capital constraints, because it requires high capital expenditure, is digital divide. The ultimate challenge is ensuring accessibility for small and marginal farmers. Particularly rice farming is mostly by small and marginal farmers. Our land holding is very small, less than 1 hectare or 1 to 2 hectare. About 92% of farmers are small and marginal in Odisha. In India, about 82% farmers are small and marginal. So the AI technology also very promising, and these are highly needed, but these are beyond access of the rural smallholder farmers. So that is a big challenge for us. So for that, prohibitive capital cost and the smallholders majority. These are two aspects which should be considered. So these can be addressed by certain policy support, targeted subsidy. Just like government of Odisha gave subsidy for line transplanting, and for similar for many activities. Similarly, for those farmers using AI tools, those using those ventures, they should be given some type of subsidy or incentives. Similarly, capacity building programs. The farmers which are not literate enough or we are not efficient in the AI tools, so the capacity building programs must be conducted for them. Similarly, rural connectivity, that is very important. If we take all these care, then definitely the farmers or in rice farming, AI will be adopted to a greater extent, and the 21st century, which poses various challenges for rice, those problems can be addressed, and rice, which is the life for the people of India, that can sustainability in rice production can be achieved. So, unlike the resilient food security requires targeted policy support, particularly the rural infrastructure and the connectivity also be established. So, there are various aspects which need attention by government and different sectors, so that the problems in the use of AI can be addressed, and the rice farming can be satisfactory, can be proceeded, and it can be sustainable. Thank you very much. So, if there are any questions, you can discuss.
No question. Nicely explained. Thoroughly explained.
Thank you, sir. As you thoroughly explained, sir, there is no question. So that is a remarkable thing for a teacher, that he is explaining so well that there is no question from the audience. And after the keynote lecture is over, then we will shift to our oral presentation. And as I mentioned earlier, I am again mentioning the rules. The oral presentation is limited to 3+1, 3 minutes for the presentation and 1 minute for the question and answering session. And our first oral presentation is for Professor Narayan Sahu, sir, Professor of SOA. Sir, please, I would like to invite you, sir.
esteemed chairman, co-chairman, respected head of the departments, distinguished professors, researchers and participants, and my students. And lastly, my dear faculties. So today I will speak on artificial intelligence and machine learning and drone assisted farming for enhancing bamboo production and productivity nodes. I am going a little away from the core agriculture. This is non-agriculture. It is not coming under agriculture. Anyway, but this is a promising sector. That's why I decided to speak on. So here let us have a focus on scenario of bamboo production. And when we talk about bamboo production, so China, our neighboring country, is producing 30 million tons per annum over an area of 6.73 million hectares. But India is producing only 15 million tons annually from over an area of 13.96 million hectares. That means India has to produce by matching with China 60 million tons because the area is more. But here we are lagging behind. And at the same time also Odisha is producing 0.4 million tons annually, that is 2.67% of the whole of the India production. Then another thing is there because we have only 136 bamboo species in India, whereas in China it is 400, in US it is 500. Then here, so I am just showing the bamboo resources in India, the statistics of bamboo resources in India. Here we can mark from the table that the production is drastically reducing from 2017-18 onwards, and now, so the Odisha is producing only 0.2 million tons annually, 0.2 million tons. That means 2 lakh metric tons per annum. Here, these are the constraints the bamboo production is facing in the state. The first one is non-availability of the quality planting material and its quality and its quantity. Then second one is age-old methods of cultivation followed. Then inadequate training, facility and capacity building of the farmers. Then climate change and natural disasters. When you talk about natural disasters, cyclone alone is not there, so there is also forest fire. So that should be taken care of. Then inadequate irrigation infrastructure is there because there is no provision for irrigation as far as bamboo cultivation is concerned in Odisha or in India. So here the fragmented supply chain and a lack of proper marketing system, then shortage of labor and skilled labor also, then low productivity, the decrease in production area, lack of younger generation interest, the regulatory and policy hurdles of the state and center, then financial constraints. So many constraints are there. Then here let us have a focus on silvicultural challenges. In silvicultural challenges, let us focus on this clump.
How your slide is not changing?
Okay. And here, so overcoming what are the silvicultural challenges we are facing? Nowadays, clump congestion is a major problem in bamboo cultivation. That's why clump management should be done in the finest way. That's why we are talking about AI nowadays. Clump congestion means overcrowding of overcrowding of clumps with bamboo clumps reduces the light penetration and air circulation, leads to poor column growth, lower productivity, higher pest incident, requires periodic thinning and proper clump management. Then coming to pest and diseases issues, and common pests include bamboo borers, termites and leaf feeders. Fungal diseases may affect column quality and plant health. Lack of systematic pest monitoring and integrated pest management is required. Then traditional inventory. We are following traditional inventory.
How shall we complete within 1 minute? Because time is 5 plus 1 minute.
Okay. So there is a problem while designing the traditional inventory because now inventory can be accelerated using AI. Then AI integrated with other systems like IoT, robotics, and asset drone technology. Then inadequate silvicultural practices are there because proper scientific spacing and plumbing and nutrient management cycles are not following properly. Then silvicultural challenges are coming into the front. That's why we need the technological integration. We have to use remote sensing and GIS. We have to use Internet of Things. We have to use drone technology. We have to use also robot technology to integrate all these to develop the inventory of the resources, how much of resources is there and in what condition they are. Okay. Then here is the bamboo chain. Bamboo chain, you know, so a lot of products can be generated from the bamboo, which bamboo is properly harvested and seasoned and also processed. Yes, okay. So here we are talking about smart bamboo in this AI era because predictive growth modeling is there because we can forecast a yield from the predictive growth modeling how much yield we are going to get. Then autonomous pest detection is there with the help of use of high spectral drone technology. Then we can optimize also harvesting cycle using data analytics and which is a part of also artificial intelligence. Then for smart bamboo, okay, we have already talked. Then come to digital roadmap. In the digital roadmap, there are 4-page execution strategy. So we have to focus on data foundation. For data foundation, why we are doing? We are building the knowledge base very strongly. Then also we want to deploy the IoT technology. That's why we want to need a real-time monitoring of different parameters in bamboo forestry. Then also we have to model training development. Training development is continuously we train. We have to upgrade the AI technology so that the intelligence building will be proper. Then we have to use also smart analytics for full-scale optimization. We have to optimize everything. Optimize nutrient, irrigation, then pest management, everything, and also supply chain. Then go to then here precision inventory management. We have to take the help of the LiDAR. The digital point clouds, that means using laser pulses and drones from ground sensors or ground sensor to create a high resolution 3D map of every single bamboo stump, even in the denser clusters. Then biomass estimation, accurately calculating the total standing volume and carbon sequestration capacity without putting a single ton. And here, this is the LiDAR precision inventory of bamboo. How precisely we can do all estimate. And the carbon sequestration I have talked. And coming to the last, the precision nursery, because you know the real, actually the real success lies with the precision nursery development. Precision nursery development can be done with the help of AI integrating with all other technologies together. That's why there is called agriculture 4.0. That means AI, then IoT, then drone technology, and also robotics. And so this is very much needed. So my conclusion is that so AI-driven precision bamboo forestry need to be established for sustainable future. So that is my advocation in this presentation. So AI-driven precision bamboo forestry is a need of the hour that must be established for sustainable future. That means this bamboo production will be a sustainable one if we follow the AI-driven policies and AI-driven also decision making, and accordingly we have to act. Thank you very much.
So any question?
Any question? Any doubt? This is a promising area. Actually, this is unfocused as far as Odisha is concerned. Odisha is not paying due attention to this bamboo cultivation in the state. Other also country also this sun pet is used there.
So how this yield is predicted, particularly in 30 million tons? Bamboo yield of India. That 30 million tons just in first grade.
Yes. What?
How it is computed?
It is computed using AI camera. Through AI camera, isospectral camera we are using, and AI camera will count how many numbers are there. Also drone also can assess. Drone also assess individually, clump wise or even column wise, even plant wise also. Because the counting by manual is very difficult task. It will take long time and a lot of money will also involved. That's why you want to decrease the cost of cultivation or cost of harvesting also. That's why you are taking the help of isospectral camera. And you have heard about the AI camera in your last Kumbh Mela, because how many disciples are coming, how many religious people are coming to have a holy bath in the Kumbh Mela. So they have found that very perfectly.
Bamboo is mostly grown in the northeastern states of India.
Yes.
So are these high spectral camera installed in those states to monitor what is the production of bamboo?
Yes, yes.
This data 30
No. One tower will be framed.
That
That
is the theory part one can do. That is the technology available one can do. But this data is estimated data or really data from the spectral camera?
No.
Data
Data
is the camera installed in northeastern states.
Northeastern
The
states.
major bamboo growing area.
It can be because
it can be. My question is.
But I have not seen
estimated.
Estimated. Yeah, it is estimated. But it can be done because
yes, can be done. No, there is no doubt about it.
Because when a light is passing, so definitely reflection is coming back. Accordingly, then you can estimate.
So any other questions? The next.
Thank you.
In which area this type of research work you have done?
Area, because this is only planning, sir. This is we have make a planning, systematic planning. What should be the bamboo future in coming decades? That's what we have planned. This is only planning. Planning and execution, these are the two pillars, successive pillars for any outstanding research work to be worked.
That means the topic that you have given here is just theoretical.
Yes, theoretical. Yes.
Just theoretical.
Because I have collected
no experimental.
No experimental.
No experimental. No. And so also we have not analyzed the economic condition also.
Economic, that is another part, sir. It will take a long time because there is another.
Because this is the
it can be done. Economic part can be analyzed, no problem.
Practical oriented problem.
Next.
Okay, thank you.
Thank you, sir. So whether it is a research oriented or it is a review oriented, the research is always a research. So I would like to call our next participant, who is Sheikh Suleiman, he is student of OUT. Please come to the stage.
So all presenters should restrict their presentation to 5 minutes.
Yeah, all the presenters should be restrict their presentation to 5 minutes. So please, Sheikh Suleiman.
Good afternoon, everyone. I'm Sheikh Suleiman. Right now, I am currently pursuing my MS entomology from OUT, and I am working on the topic development of protocol of green termiticide in my research. So, for today's international symposium, my topic is related to the artificial intelligence, the intervention of artificial intelligence in botanical nanotechnology for sustainable precision pest control, which is related to termites. This topic mostly covers the future perspective and possible AI interventions in the loophole of termite monitoring. This is the overview of my topic. And why termites? Termites, it is because of the complex nature they have. And when we talk about termites, they don't have any kind of economic threshold level. And whenever a person sees a worker termite on some crop or furniture, there is a high possibility that a long colony or a large colony has been established there. And because of the high fecundity that termite is having, to control them it is very difficult. And mostly the option we are left with is a conventional synthetics. So currently we are working on the green botanicals for tackling this problem of termite. The major problem in controlling termites is the cryptic lifestyle, the zero ETL conundrum, eusocial nature, and biochemical defenses. Because their diet is consists of lignocellulose, they can develop the resistance rapidly for that conventional synthetics. These are the detoxifying enzymes insect produce cytochrome, which create resistance against synthetic pyrethroid, carboxyl esterase, and glutathione transferase against organophosphates. The role of nanodermaticide. The nanodermaticide helps with the enhanced penetration and evasion of defenses against these cytochrome glutathione transferase. These acts as a Trojan horse for co-delivery. Generally, when we use conventional synthetics, this kills the termite workers at once. And when we search for chronic poison, which creates chronic toxicity, there is a high chance that the worker may transfer that to the queen, and which may help in collapse of the colony. And this can solve the problem from deep root. This is the comparison between conventional synthetics and green termiticides. The green termiticides will always have an upper hand in facing the ecological consequences, but it comes along with a few negative impacts. And the AI intervention, which is I found that is the deep lab cut software. This software has recently been used for Hertameter for monitoring the behavioral changes. Termites have this special feature of prophylaxis, ataxia. Prophylaxis means mouth-to-mouth feeding, and ataxia. If we are able to determine whether that termite is facing that sublethal toxicity, there is chances that the worker termite may carry that to the queen termite, and it may result in collapse of colony. The deep lab cut and the termite consists of a phenomenon. There is a negative thing that we can't use a normal visible light for these termites. The infrared radiation, as the termites are highly photophobic, so use of infrared radiation can help in monitoring the termite behavior. If we are using visible lights, then the termite may show reduced behavior of prophylaxis and ataxia. In this, we are quantifying sublethal behavior. The traditional mortality curve will be measured, and the innovation of AI deep lab cut for this micro behavioral changes such as ataxia, reduced blooming frequency can be monitored. Later, we create a treatments in which we compare the chronic poisons with the normal conventional synthetics. These are the treatments from T1 to T8. Generally T6, there are many problems related to encapsulation of green botanicals. So there might be a chance that if we mix these green botanicals along with the commercial grade, this may act as a synergist and create sublethal toxicity to the termite. And this is compared with the completely conventional experiment like chloropyrifos, T2 chloropyrifos. If it is creating similar mortality rate, then the preparation of nanodermaticides, it includes the raw material extraction of the bioactive compound, later nanocharacterization. These nanocharacterization is again formulated. Later it is tested under the AI. By this conclusion, we can say that it will help in bypassing the enzyme shield. AI accelerates the discovery and validation of termite behavior, breaking the pesticide treadmill in market, maybe in upcoming days. It will ensure a sustainable future for integrated pest management.
Any questions by audience?
Mobile for question.
have one question. Nanoparticles mostly, the nano size is such that it can enter the plant body easily.
Yes.
So that nano urea and act by that principle.
Yes.
In the tormiticide, what is that principle?
Sir, actually, in termiticide, there is still commercially no nanoparticle has been developed because there was a risk for entry in humans too. Sir, and the active bioactive compound might depend on the plant extract we are taking.
How these are applied? Nanotermicides.
Nanodermatitis, sir, it depends on the formulation. If we are taking nano encapsulation or nano emulsion, mostly many of the research work is depend.
Suppose in the crop field there is a termite attack, so how it will be soil applied.
Pardon me, sir.
Then how it will be applied?
Sir, mostly on soil-based application.
If there are no questions, next please.
Thank you.
Thank you, Suleiman. So hopefully this research will address to the farmer facing the problem regarding the termite. And we would like to call our next participant, that is Krishna Kumar, he is a student of OUT. Please come to the stage.
A very pleasant good afternoon to one and all present here. I am S. Krishna Kumar from the Department of Agronomy, OUAT, Bhubaneswar. My topic is completely based on the review, not any research is conducted. It is completely based on the reviews. My topic is about AI-driven precision irrigation and nutrient management for sustainable yield maximization. Before entering into the review topic, I have to tell something about the different global challenges faced by the farmers and around the countries in the management of irrigation and nutrient. First, this is the overall water risk which is around the world. The dark red regions which is mentioned the extremely high water risk regions, and the recently in January 2026 the United Nations declares the global water bankruptcy, which means the water is at risk. So in around 2.5 to 3% of fresh water, there is 70% of water is used in the field of agriculture. With the help of the AI-driven precision management, we can reduce the water usage and we enhance the resource use efficiency. And once the Ismail Sirajuddin, the Egyptian librarian, who told that the war of 21st century will be a fought over of water, not on oils. Yes, it is being true nowadays. And then these are all the different nutrient management problems faced by the different countries. And the Netherlands nitrogen precise, it is completely based on the excessive application of ammonium and nitrate fertilizers. And in the USA, the dead zone in the Gulf of Mexico, which is caused due to the eutrophication from the Mississippi River, and in the massive green tides in case of China, which is caused due to the Alga florifera, which is the green algae, which causes eutrophication which causes massive death of the fishes in case of Yellow Sea of China. And the integration of artificial intelligence of things, which helps to transform the traditional farming from the traditional farming like schedule based application to responsive data-driven operation, and which also helps to shift the enhance the productivity and enhance the resource use efficiency of the farmer by precise application of water and nutrient. And my key objective of my reviews are to improve the water use efficiency through AI-guided irrigation and to enable precise nutrient management using IoT sensors and machine learning, and reduce the environmental pollution caused by the excessive fertilizer dose, and enhance the crop productivity through the data-driven precision agriculture. And the different methodology I have collected is, the first and foremost important thing is to collect the real-time field data. Yesterday in the symposium also, the scientists are told that the collection of data is the major lacking in case of AI-driven in the field of agriculture. So the collecting data is foremost important thing. And after the collecting data, the data are transmitted to wirelessly to the cloud and edge computing platforms. From the edge computing platforms, the data are stored, and the artificial intelligence and machine learning models, which like the random forest, support vector machines, and long short-term memory, artificial neural networks, which analyzes the complex plant, soil, and climatic interactions to forecast the exact crop requirements. And then, based on the machine learning models, the AI models, which triggers the automated smart irrigation valves and guide the variable rate fertilizer application. And I have collected the different successful case studies. The Ramakrishnam Raju et al. From the Telangana, who developed the artificial intelligence based smart hydroponic expert system, which integrates the Raspberry Pi, which is the microcontroller, plus IoT sensor and mobile app, integrating, which use the highest accuracy of application. And in case of another case study, Senadipati et al., who proposed this experiment is conducted in the Bhubaneswar, and the IoT enabled soil nutrient classification and crop recommendation. Here, the supports the crop recommendation, which reduces the fertilizer usage and increases the productivity. And these are all the different data I collected from different review papers, where how the AI-driven precision farming, which enhances the yield and reduces the water usage and fertilizer use. And coming to the conclusion that the integration of artificial intelligence and machine learning is not just an economic advantage, but an ecological necessity to achieve a global food security and global resilience. And it helps to shift the resource-intensive practice to quality optimized sustainable system. And the future outlook is to achieve the widespread global adoption. There are key barriers are there to overcoming. By overcoming these barriers, we can achieve the global level achievement of artificial intelligence in agriculture. Thank you for the opportunity.
Questions from audience. I guess there is no question from the audience, sir. So can we shift to the next, sir? Yeah. Thank you, Mr. Kumar. Thank you for showing at least the Indian scientists who have worked on this AI and all. Because most of the scientists, whatever we are researching the review, mostly it is completed by Jam et al. Only. Thank you for showing the Indian scientist research work. Okay, so we will come to the next one. The next participant, it is all about this Narottam Das, research scholar from IIT Kharagpur. I welcome Narottam Das.
Hello, good afternoon everyone. I am Narottam Das. I am presenting on the occasion of artificial intelligence in shaping agriculture and allied sectors for sustainable food security. And my topic is access to finance and financial sustainability of farmer producer companies, an empirical study. Though an empirical study, I have done some preliminary analysis. As the paper in its preliminary phase, I will present what I have done till the date. So these are the outline of my presentation. So coming to the introduction, as we all know that after the inclusion of 2013 Companies Act under Section 465 of subsection 1, FPCs are getting the corporate muscles and they are treating as a private limited company. They can now issue the shares and participate into acquiring the funds from different financial institutions. So getting financial or fundings from the financial institution is very much important. As a research scholar, I am now collecting the primary data from the field studies, and I have visited two different parts of Odisha like Jagatsinghpur and Keonjhar and other districts. They all have reported that the financial constraints are there. They are not getting enough funds. Even in Keonjhar, I have visited a FPO. They have said that they don't have an office because of not paying rent. So lack of fund is there, lack of funding is funding facilities and funding problems are there. So in this era, financial stability and financial backing is important to run a business, and especially for farmer producer companies, they are getting very less amount of funding from the government. So these farmer producer companies are generally believe in collectivism principle, means they are coming together. Most of them are marginal farmers. They are coming together. They are trying to pool in the resources to run their business and to send all their products to the different parts of a country. So FPCs also helps to address issues by facilitating credit access from banks and financial institutions at lower interest rate. Before that, the member farmers are acquiring funds from informal sources in higher interest rate, like from village zamindar and the rich persons of village. But after after being a member of FPC, they are getting loan facilities, and bank maybe have a belief on them that as they are a participating member, so they can repay the loan. So we can grant the funding facilities to them. So this is a very pictorial form. We can see that how the agri transactions are converted from traditional cash system to online systems. The 2017 data is plotted on green, and while the 2014 data is plotted on orange. So in initial phase, in case of cash transactions, 2014 is more, and in case of all transactions through financial intermediaries, green line is more. So we can say that there is a shifting in financial transactions. So due to limited time, I would like to conclude very easily and very shortly the empirical literature, where the access to credit is a important factor. Then investment in assets and technical training is playing main actor to run a business, and regional banking outreach and expansion of rural bank branches are boosting the savings and investment behavior in rural agri business. So apart from that, the governance, quality, infrastructure and business planning are also crucial, and market access is very important and topic of discussion. And the farmers who I met, they all have raised the question that the products we are making, the products we are producing are not marketed because the marketing facility is not there. Then, so these are some important questions. We can get that how much the FPCs are financially sustainable, and does the financial development in India affect the financial sustainability of FPCs? So, following the research questions, I have shared the objectives for my study, and to analyze the objectives, I have collected the data from 21 farmer producer companies and the data span is for 5 years. And all India level pharma producer company data I have collected, and here is the regression model I have used in my study. So these are the variables, and here is the summary statistic in the mean of the ROE. ROE is the financial performance metric which we are using to check whether the financial performance is better or not. And if we go to the correlation matrix, then we can see that there is a positive correlation between financial development and ROE, and along with profit and cash and bank balance, and state agriculture to state GDP to agriculture are positively correlated with the farmers' financial performance. Then we can see the regression results that financial development, log profit, and cash and bank balance are positively and significantly affecting the financial performance and sustainability of farmer producer companies. Means if the more financial development is there, more banking facilities, more online disbursement facilities, then the performance will be better because they will get more grants, more loan, and more funding facilities. So if we go to the findings,
already 6 minutes.
1 minute. Factors like improvement of financial knowledge, awareness will be a boon for the farmer producer companies and farmers, and advancement in fintech services, financial development, improvement of the financial performance, and it will lead to a success for the farmer producer companies. And GDP contribution is remain insignificant because there are very less contribution of farmer producer companies towards the GDP. That's why it remains like insignificant. Hopefully, it will go up in future. And in the last, we can say that routinely training program, capacity building program, and awareness program, and especially the marketing facility will boost the income and financial performance of farmer producer companies. So these all factors will lead towards the Viksit Bharat of farmer producer companies and agriculture of India. That's all. Thank you.
Questions from the participants. I have one. You have mentioned about profitability
Yes,
of
sir.
FPO.
Yes, sir.
Which are the factors that contribute to profitability?
If we talk about profitability, the first factor is the revenue. That how much revenue is earning by that company. So the how much sale is doing, and how much cost is there. So if the cost is less, then profitability is more. So in preliminary phase, there are most of the FPOs are not profitable because of cost is more, and sale and revenue is less. That's why profit is there, but not in a significant manner.
And then if cost is more,
cost is less.
The cost is less. Which are factors governing profitability of one FPO?
Which is there, how they are try to reach their products to the different regions of the country, and how much they are selling.
From production process to marketing, there
Yes.
are many steps are there, and each step contributes to profitability.
Yes, sir.
Many steps there. Suppose selection of technology, that is also
Yes,
one
sir.
important.
Yes, sir. Yes. Yeah, as this study is in its preliminary phase, I will look into all these factors like AI and technology, how they are contributing to the profitability of the farmer producers.
Okay, thank you.
Thank you, Narottam. Quite good presentation over here. I wish the IIT should go for the MOU with the various ethical institutes to do research like this. And I will call my next participant, that is Dr. Avinash Patnaik. He is the assistant professor at SOA, and I welcome you, sir.
Thank you, Devashish, and very good afternoon to one and all present here in the auditorium. And my topic for today is under the first theme, that is enhancing resource use efficiency and agriculture productivity. So the title basically we have is my PhD research which I have done under Dr. Kashila Devrana, and so we have as we are talking about enhancing the resources, we have collected the resources which is available in Odisha, that is collection of the and characterization of sacred lotus genotypes of Odisha. So we need to understand over here first why we are talking about lotus. So when we are talking about lotus, we think it is as a ornamental crop, but it has a lot of other uses, and it has potential in agriculture factor. So apart from a flower, it can be used as a vegetable. Its rhizomes are used for making vegetables, and also the petals are used for making gulkans, and also these days fibers are used. So it has a lot of, if you talk about in a commercial point of view, it has a lot of potential, not only floriculturally. And if you talk about in the agriculture fraternity, these days we are talking about this crop is not got its potential which it should get as a national crop. And so here we have collected, so the material and method, it has conducted in OUAT in the year of March 2021 to February 2024. And within these 3 years of period, there are like 19 genotypes which we have collected from different parts of Odisha, and we have replicated it twice. And we have used different softwares, STS software, where DMRT analysis has been done. So we have collected these data and used softwares through which we have analyzed. So this was one of the first attempt of on lotus. Before this, there is no research has been done in this particular crop. And so this is the overall view. So we have got the rhizomes and we have planted in 3 feet. The major constant when we talk about lotus, it's an aquatic plant. So we cannot go into a water body, and taking data will be difficult. So we have constructed these cemented wells, 19 cemented wells over there, in which we have filled with sand, and different genotypes that we have collected has been planted in these 19 wells. And based on that, 3 years data has been collected on different vegetative and flowering characters. And so these are the different parts or the different districts of Odisha from where these 19 germplasm has been collected. So basically we have collected the rhizomes over here for the easy establishment. And when we collected it, we didn't know what is the color, what is the shape, what is the size. So we have named it as or notated as Odisha lotus, or notation as OL. So as you can see, this is OL1, OL2. All the lotus are of different color, shape, size. They have different petal arrangements. These are not hybrids. These are our own local native resources, which has never been documented. So this was a very first attempt to document it. And accordingly, with a period of time, we have given the names which are gone for the multi-locational trials. And so these are the specific names and different types of these 19 germplasm which we have researched on. So coming directly to the result and discussion. So morphological descriptors. So there was no morphological descriptors were there. So based on these color, shape, size, so I have restricted the color of petal of pink, light pink, deep pink, and white color. So the dominating color is your light pink, and the flower type we have single and double type, in which mostly the germplasm that we got is single type, and the flower stalk has short, medium, and long. So major of the flowers were medium and long types, not very short types. And flower stalk curvature was erect and curved, in which mostly are erect types. So coming to most of the characters which we have, yield attributing characters, I have tried to focus over here. So the days of bud initiation after getting the physiological maturity, the first germplasm which flowered or initiated the bud was OL10. That is within the 14 days of attaining the physiological maturity, that is 3 months period. After 3 months of the physiological maturity, in 13 days it give the first bird. As you can see in the picture, there is small bird has been initiated. And next character is number of flower per plant. So OL10 has given the highest number of flowers per plant, that is 30 numbers of plant. If you can see the graph that we have shown over here, OL10 has the highest graph. And next is the length of peduncle. Why we are focusing on the peduncle? Because peduncle gives the fiber. So it is another attribute which not only important as a cut flower, as a loose flower, but also for the extraction of fiber. So here you can see the OL6 has the highest 125.45 centimeter, which has exceeded a 30 centimeter scale also. But there are also germplasm which are short in peduncle length. Then coming to the flower diameter, the flower diameter highest that we got is OL6, that is having 28.75 centimeter, which is quite a big size of flower, which is a single type flower. But here you can see there are also double type flower, which is white, there is deep pink in color, but their size of diameter has been varied over there. Then coming to the petal, number of petals. So there are as we discussed, there are single type of flower, there are double type of flower. The single type of flower has 15 to 20 petals, whereas the double type flower has more than 150 to 200 petals it could be. So OL2 has got the highest number of petals that we have documented, 161.14, and the lowest one is 15.5, which is mostly for the single type of lotus that we can see. The last parameter that I'm going to discuss here is the flower weight, which is very important. When we are going to sell our flowers, the flower weight is also important. So the highest we got for a double type of flower, it is very visible that it will be having the highest weight, that is 55 gram. And so I would like to conclude here that for any type of crop improvement program, if we collect these kind of local germplasm, for a sustainable agriculture thing, we can exploit these characters, like where we have got the highest number of weight, the highest number of petals. So these could be used for crop improvement program. And as OL10 has given the more number of flower and these things, so could be exploited commercially for the cultivation. And so this is what I would like to conclude my presentation with. Thank you.
Question from participants. So you have collected many germplasm.
Yes, sir.
And also characterized.
Yes.
So how AI can be utilized in future for your research? Variety development.
Sir, as we are discussing about AI, I think AI is all about, as previous authors over here who have presented, they said it is all about data collection. If we have number of data and things, so through bioinformatics, we can utilize these data for any kind of a genetical information, and how we can see genetically they are different from each other based on these morphological characteristics. So that is what I think. I don't know much about how AI could be, but this is what I have assumed from the discussion that is going on around here.
How can you use this information for developing a variety?
So that is what I'm saying, like based on these data, if you do a kind of a genetic characterization or run these data, we can see a genetic diversity we could see. So based on the genetic diversity, we can get a dendrogram through which we can see how much diverse they are. And we can do the crossing between these kind of germplasm which is having the wide distance in the dendrogram. So they are genetically, they can be crossed to prepare new, to get a new hybrid.
Thank you.
Sir. Yes, sir, parentage and also the distance, how.
What's happening as about the inflation in AI?
Yes, sir.
You have already standardized the number of petals and morphometric characters.
Yes, sir.
Once these are fed into AI,
Yes, sir.
you can scout out in Odisha what is the population and where it is grown profusely. Which
Yes,
right
sir.
now you are only collected, but you don't know where they are structured and
Yes, sir.
distributed.
Right.
The distribution pattern can be very well studied and exploited.
Oh.
I believe so.
Thank you, sir. I would try this. Okay.
Because optimum depth of water is needed for good fruiting.
Yes, sir.
So that's why how much is the optimum depth that should be decided. And if it is not that, how to control that with AI, the application of AI, you can do that.
Okay.
Another, are you adding any nutrient to the water?
No, sir. Basically, when we did the research, we didn't add much of nutrient. Common nutrient that we have given is the cow dung. Yeah. So because it needs an acidic condition to grow, so a cow dung slurry has been applied and a common clay soil along with the effluent was done while doing the study. And gradually, what happens? The leaves get decayed. So it creates a nutrient for the plants in the microclimate itself. So we didn't have to add any fertilizer in these 3 years of period.
Another thing, suggestion, that is,
Yes, sir.
because over an area of half acre or 1 acre, if you develop this lotus cultivation,
Yes, sir.
what will be its economic benefit? If a farmer goes for half acre or 1 acre,
Yes, sir.
And goes for this lotus cultivation,
Lotus cultivation.
then how much profit will be generated? Whether it is feasible economically or not?
Yes, sir. That is what.
It is a sustainable one or not?
Yes, sir.
That was
So actually, lotus is a miracle crop. So many things we have to do, but it is an initial work, and we have collected 28 kinds, and out of that, 19 have been identified properly from different states of different districts of Odisha. He has taken lots of data, but we have not given here because he has to publish so many papers like heritability, genetically advanced correlation, path analysis, selection indices, D-square, everything he had done. So only thing is, because this is one theme was the production technology, that's why he has given. And as far as this yield is concerned, and this economics is concerned, I can say that for 1 hectare of lotus cultivation, one can go for planting 4,400 plants. Okay. And if we will sell the flower from that, suppose 25 to 30 number of flowers will be produced, then you will get 1 lakh flowers. Okay. Then for 1 lakh flowers, even nowadays you can see 50 rupees or 100 rupees per flower people are selling. But if you will sell in 10 rupees, then you can get 10 lakhs. And your maximum, cost of cultivation will be around 1.5 to 2 lakhs. You just imagine how much you will get. Another thing, so many things are there in this lotus because you can go for harvesting fiber from the peduncle of the pink color lotus, and that is giving you the maximum, the highest costly, very costly silk. And mostly in Cambodia, they are producing this silk for creating these robes for the Buddha monks. Okay, so it is very costly than anything. All kind of this here. And the seeds. And seeds are, I can say, it is full of nutrition as well as medicinal properties they are having. So many things, your lotus seeds, your nephrin, your luciferins, so many alkaloids, flavonoids, antioxidants are there. So we have harvested on flower. You can sell the rhizomes. They are also very good, and the rhizomes and flowers are used for preparation of the tea. And that is nowadays very important because everybody is trying to lose weight. And this lotus leaf and the flowers are taken for preparation so many things. So it is a miracle crop. Each and every plant is useful. And this is the initial work. And this work is we are continuing. And in SOA, we have established one lotus gene bank. And already this Abhinas has planted 11 kinds and we are now going for another 13 types, and whatever available in Odisha we will go for, and also procure from China, because China is doing this lotus is our national flower. China has done more work than India. So thank you, thank you.
Thank you, sir.
You have mentioned the days to flower bud appearance. And
Yes,
then
sir.
the range 10 to so many days.
Sir, actually I said physiological maturity takes 3 months, and after that it is 14 days or 15 days. So the growing period to attain the physiological maturity or the vegetative growth is 3 months. Minimum is 3 months.
In the 10 days you will get.
So that is or after that 3-month period. So I have not mentioned, I could have put a star mark. It is I said that it's a physiological maturity after 3 months is the date of initiation of the bud. So 30 days plus, 3 months plus that 14 or 10 or whatever days.
Okay, thank you.
Thank you, sir.
Thank you, sir, for having a loquacious presentation. And I will call my last participant, Dr. Pradosh Kumar Parida. Is he present over here? Pradosh Kumar Parida? Okay, if he is not, then we will like to conclude the session. And in the concluding session, we will go for the first. It is all about the remarks by our chairman, sir, and the co-chairman, sir. Sir, please have your remarks on this entire session, sir.
So I shall request our co-chair to give his views. So during this session, a total 5 number of papers were presented, and those papers were from diversified field, starting from bamboo cultivation, how to enhance its potential, and to lotus cultivation. So starting from bamboo and ended with lotus, and all these papers, there are some innovative and also idea how to incorporate AI tools to enhance the production of productivity as well as the profitability. Though we are in a very nascent stage of application of AI, and always there is a huge scope in all the fields of agriculture to apply this AI and other tools. And gradually we will be moving in that direction. So all the papers were mostly, except few, are literature based or review based paper, and hopefully that must have enlightened our audience, their vision and also the scope of AI.
So thank you. So in this session, total 2 lead papers and 4 papers have been presented. So in the first lead paper, Sejukta Sambit Tripathi, he actually very nicely discussed about opportunities and also possibilities. What opportunities now available with respect to AI, and also what are the future possibilities. With respect to that, he mentioned how in turmeric, for prediction of price, the AI tools can be used. Similarly, for climate predictability, for even water use efficiency, enhancing water use efficiency. So how AI can be used, that was discussed by Tripathi. There was a good deliberation. Next presentation by myself, I actually discussed the overview of how the AI and various tools can be utilized for facing the challenge faced by rise in the 21st century. And other presentations, particularly the participants, they also presented very nicely with respect to our presentation on bamboo production, how AI can be utilized for bamboo nursery, and how bamboo production can be enhanced, like based on certain review. Then also one paper on a nano tormiticide. That was also a nice presentation.
then presentation by Krishna Kumar, and then presentation by Narottam Sahu, Narottam, and also the presentation on the last presentation on Lotus, that is a very good research work, particularly with respect to collection of characterization. So all the presentations that are very good, they were presented nicely. And as the objective of this symposium is artificial intelligence and how it will shape agriculture and allied sectors for sustainable food security. So all presenters, they have tried to incorporate or at least to how utilize AI for that research purpose or for that all each aspect they dealt. So, however, with respect to objective of this workshop, the presenters have tried their best to present their research work in the lens of AI. And so, finally, I thank all the presenters and also all the participants for their patience. Although it is now approaching 2 p.m., till then all are present. And also I present the co-chair and also the rapporteurs and particularly the organizers who have nicely organized this symposium. So with this I thank once again all. Thank you all.
Thank you, sir. Sir, you have made my job very easy. To be very honest, you have already given the vote of thanks in your remarks point. But it is the time for the felicitation, and I would like to invite Dr. Alok Nandi, sir, to be in the stage to felicitate our chairman and the co-chairman, sir. Sir, please, sir, be on the stage, sir. A big round of applause for Alok Nandi, sir. And I will request all chairmen, sir, and co-chairmen, sir, to be in the stage. And I will also request our rapporteurs. They are doing their tireless job in writing our entire decision to be in the stage as well. So, volunteers, please join the stage so that our chairman, sir, and the co-chairman, sir, they could be felicitated by Dr. Alok Nandi, sir. A big round of applause, sir. Thank you so much, sir. Thank you so much, sir. So, on the thanks remarks, on the vote of thanks, I would like to thanks to all the audience present over here and all the media team and our chairman, co-chairman, the rapporteurs, all the scientists and the participants who are present over here. And it's time for the lunch, and we should have the great lunch. Thank you all.
Thank you.